Good morning, sir.
Good morning. Good morning.
Sir, your voice is not audible, sir.
Now again. No, but you said that
Voice
my
is
voice
not
is coming that
audible.
time. What?
Abhinay sir, pin the profile of Professor Teacher sir. Kindly pin the profile.
नरेंद्र सर की भी सुनाई नहीं दे रही है, आवाज बंद है. हाँ, now it's
Huh?
yes, sir.
No.
So fine, sir.
My voice is coming now.
Yeah, yes, sir. Fine, sir. Yes, sir.
Okay, let me now you tell me just 1 minute. Now
Now, sir, fine. It is coming, sir.
this one is better or real one is better?
Earlier was better, sir.
Huh?
Earlier one was better, sir.
No, you just see again. See, I am speaking now. Just see.
Okay.
1, 2, 3. 1, 2, 3. Okay. Now just
Okay.
check. Now, what about
Sir, this
One,
one,
two,
second
three.
one. Second one.
This one is better. Okay.
Yes sir, it is much better sir. Good morning sir.
Okay. Because then I was using 2 speakers, but anyway, so this one, if you are telling that, okay, then fine. Okay, if there is any problem, then you tell me. Okay. In between.
Sure, sir.
Yes. Okay. Yes.
Shall we start, sir?
Okay, we can start. Okay. So I should present my this one screen now. Huh? Okay. Yes.
So firstly, okay, so I just want to talk to the participant. Dear participant, kindly mute your mobile mic so that no hindrance during the session can take place. And Professor Dikshit is with us. He has already taken one session, that is after the inauguration function. Now today he is going to discuss about the cost analysis in the manufacturing part. So I forwarded to Professor Dikshit. Sir, please, sir.
Okay.
You can start, sir.
Yeah, let me just share that screen. Okay. Share. Okay, yeah. Just a minute. Talk. Okay. Talks. This is my teacher. Okay. Are you seeing my slide?
Yes, sir.
Yes. Okay. Fine. Okay. In that case, if there is any problem, then you indicate and you can phone me at design number. Okay.
Sure, sir.
Yeah.
Sure, sir.
Okay. Now, today we are going to discuss that one thing. In fact, I want to draw the attention of the participants because most of you are doing research in manufacturing. I know a lot of investigations you are carrying, but hardly we spend time for cost estimation. Now, as you know that nowadays, suppose ultrasonic assistance in manufacturing process has become very popular. Even Dr. Aviral Mishra also has conducted his thesis on the use of ultrasonic vibrations in improving the quality of magnetic abrasive finishing process. Okay. Similarly, in other areas, many metal forming, casting, everywhere we are talking about that type of thing. That is one example that ultrasonic assistance is helping. Many people call it hybrid manufacturing also. Another example is that minimum quantity lubrication. Then people are using cryogenic cooling, where they are using the liquid nitrogen to cool the tool. And they are generating a lot of results also showing that there is a 5% reduction in the force and this much an improvement in the surface roughness. But the question comes from industry point of view. This becomes very important that if you are gaining something, at what cost? So hardly I have not seen such type of papers, because most of these papers, they describe the physics. They are published in good journals which are oriented towards the mechanics and physics of the process, manufacturing journals also, but they are not actually commenting on the cost aspect. It is true that suppose you use liquid nitrogen, then your tool life will improve. But then how the liquid nitrogen is generated? What is the energy consumed in liquid nitrogen? What will be the cost? Will it be feasible? Minimum quantity lubrication you can use, but you have to give extra attachment, whether it is justified or not. Ultrasonic assistance, then you have to make some arrangement for ultrasonic vibration. This will be useful or not. All these aspects have to be studied. So that is why my talk, although I will be taking one example of 3D printing in the cost analysis, nevertheless, it is general. That means you may be working in any area. Suppose you are working in joining, or somebody is working in casting. He can also take benefit of this. Somebody is working in EDM, ECM. They are also the same type of methodology can be adopted. In each even PhD thesis, there can be a small chapter or section on the cost estimation. So cost estimation is the process of estimating the cost of a product before manufacturing, or it is considered forecasting the future cost of a product. But one should not think that this is very trivial and given. Okay, this cost estimation is very difficult. It's not that easy task. It requires some skill. If you do underestimation of cost results in financial loss of the business and hampers its growth. And if you do overestimation of cost, then it will make the loss of goodwill of a company, industry, and customers. They will not be satisfied, because they will think that you are always overestimating and you will not be competitive in the market. So proper cost estimation is important. Why do we have to do cost estimation? Because we have to identify business potential and obtain competitive advantage. If I make the ultrasonic assistance, whether it will be, I will be able to sell in the market, will I be able to make the profit? These are important questions. Then perform break-even analysis. Like suppose I am giving extra feature in my machine, then minimum how much production rate should be there so that my machine will be profitable. For that purpose also you need to have good cost estimation. Then prepare production budgets. Okay, you have to prepare the budget for 1 year, so you should know beforehand. Set product price and provide accurate quotations for customers. In industry, often this job is done. That skill has to be learned by engineers, that when they, particularly those who are in marketing, they make the estimates of the prices and then they give to customers. They make decision regarding changes in manufacturing processes. That means, as I was describing, it is connected to that suppose you want to add some extra feature and you are changing the manufacturing process, you should do the cost analysis. So ultimate aim of cost estimation is to ensure profit to the industry. And cost estimation is an important part of sustainable manufacturing. As you know that sustainable development meets the needs of the present without compromising the abilities of future generations to meet their own needs. And this is an important part of Industry 4.0. In the sustainability, we have three main pillars. That is, one is social, other is environment, and third is the economic. So where there is economic, there the cost also comes. If a manufacturing process is good from the society's point of view, environment's point of view, and economic point of view, then the process is sustainable. So now what are the features of cost estimation? Cost estimation requires technical, administrative, as well as managerial skills. You have to understand the technicalities of the work, but also that how it jobs are managed, whether it will be how many pieces will be there, whether it will be mass production or batch production, all these aspects have to be considered. To estimate the cost of a product, it is necessary to find the cost involved in manufacturing operations. Now, there are several techniques and methodology. I will be discussing only a few of them, but there are many methodologies. So what is manufacturing cost? That means any expenditure that is directly or indirectly involved in the manufacturing process. It is the summation of the costs of resources consumed in each and every process of manufacturing the product. And different elements can be material cost, labor cost, machine cost, and administrative overhead. These are the four main attributes. Material cost is we need variety of materials, and it is not only the raw material which makes the job, but you also have to consider consumables like coolants, etc. Then you estimate the weight of the material required to make product, and then how much is the ordering cost, how much will be the loss of the material. Like in 3D printing, suppose you are making some part by selective laser sintering. There you put powder. Only some portion of the powder is used for making the job, remaining gets wasted. So if you just make one product, in that case, lot of powder may get wasted. That also has to be considered. So material cost will be direct material, then loss of the material, then indirect material, means supporting material like coolant, etc. Then ordering charges. These are the main element in material cost. Labor and operator cost. It is the cost involved in running and handling a machine, especially during its operation. Operator cost, etc. comes. Labor cost depends on idle time. You have to consider that sometimes labor will not be doing any work. Overtime, number of shifts, efficiency of the person, and number of workers present in the industry factory. In the present era of automated manufacturing, the labor cost actually has becomes less significant because of the that percentage contribution. But and moreover, a single worker is trained to operate several machines. You have to estimate that very accurately that how the labor cost will be divided. Machine cost is basically it may be very significant contribution because some machines are very costly in modern manufacturing processes, and you have to include the cost of machine, and it is generally taken through depreciation. Suppose you purchase a machine and you say that I want to divide the cost of the machine to 5 years. The straight method can be just divided by 5. Each year you recover that much cost. So that way depreciation cost is calculated. Then power, energy, then other utility, that means things needed for operating the machine, then maintenance, and then insurance, etc. of the machine. That also insurance, interest, all these aspects have to be included in machine cost. Overheads are associated with a facility or a department in an organization, and they cannot be identified or attached, associated with any product actually so easily, because it is like cost of a manager. Overhead cost cannot be identified with a particular unit of production. So in general, it may be factory overhead. You have a lot of big buildings, so to maintain them. It may be in the sales department, marketing department, research and development, and some legal cell is there. All these costs have to be considered in overhead. Now, there are broadly two types of cost estimation techniques. One is quantitative, other is qualitative. So quantitative technique is based on detailed analysis of the product design, features, and corresponding manufacturing processes. When you design a product, you know all the details about the design, and you also know that how it should be manufactured. So based on that, you can do the analysis, and it is so you have to consider different parameters. And qualitative is that based on a comparison with a similar type of product, you can get information from past data, and based on the judgment, you can actually estimate the cost. So In the quantitative method itself, there are many techniques like activity-based costing, breakdown approach, feature-based approach, and parametric techniques. And in qualitative, we have case-based technique, case-based reasoning, regression model, expert system, and some are soft computing techniques. There are some papers where people have used neural networks also for cost estimation. They give a lot of data to neural network. Neural network is trained, and once it has understood that for these products the cost is this, then it can give the idea about any new product also. So we'll discuss a little bit about quantitative cost estimation techniques. So one technique is popularly called activity-based costing. It was practiced by small to large scale industries since 1980s. In this, what happens, it allocates overhead to different activities. Generally, allocation of overhead is not very scientific. That means they may give that something like 5% of the total cost of the product goes to overhead, like that. It really recognizes the relationship between cost, overhead activities and manufactured products. It is a part of management that focuses on achieving profit by managing activities. And challenge is that sometimes the indirect costs such as management, salary, staff salary, very difficult to associate it with the product. So it focuses on identifying all the activities associated for making a product or doing a process. That is why it is called activity-based. And it measures the business performance activity by activity and identifies the process efficiency and effectiveness. If an activity incurs high cost without adding any value to the product, then re-engineering is considered to achieve cost benefit. So like activities and costs are related, machine handling, how much is the cost running of the machine, then material handling, then purchase order of products, like that they do. Another is the breakdown approach, in which cost is broken down for a product into number of components. Like here it is total cost, material, design, floor space, utility, software, labor, and then after that you do the analysis. So breakdown approach mostly is more scientific. And now qualitative techniques are case-based reasoning, in which previous product we compare with the previous product. It is helpful in making reliable estimates at the conceptual design stage, because you don't have much information. So you don't know that how it will be manufactured. You don't have, so it is very difficult to do that breakdown type of approach. But you know that similar type of product was manufactured and its cost was like that. So in that ratio, you can estimate the cost. And past data should be used wisely. Regression analysis makes use of historical cost data and establishes a linear relationship between the product cost and the value of certain selected variables. Like suppose you are making some, let us say, chairs, then maybe the size of the chairs, based on that you can do the costing. The established relation is then used to forecast the cost of a new product. And now I am going to describe that specific work about that additive manufacturing process. You know, we have used a fuzzy set-based cost model, and now my student is still working on that, and we have published some papers. So in the additive manufacturing process, like 3D printing, etc., you have different components of cost, like material cost, raw material, additives, support material, and post-processing material costs. Operator cost will be, in fact, even the software engineer, if he is there, that cost will also be included. Machine setup, running and post-processing operation costs. Then slicing cost means that, okay, slicing and operator cost has been split. Slicing cost means software and designer cost. And overhead cost means machine depreciation, maintenance, consumables, electricity, factory rent cost. And so several steps are necessary. First step is the listing of various activities. First we do pre-processing, that means we design the CAD model, then convert it to STL format with file transfer and setting up the machine is done, then processing is done, and then after that post-processing means we take the part from the machine and then So first we have to spend some time in the part removal, then we clean it. Sometimes we take it to another machine and we do finishing also, because many additive manufacturing processes do not give very good surface finish, but that surface finish is obtained by subtractive machining process. That cost also has to be included. And so one important thing is that if you want to do proper cost estimation based on the breakdown approach in additive manufacturing, then you have to estimate the time. Time estimation is very important. How much time will be required in that your machine, because machine is very expensive and time is important. So cost is calculation is carried out by using appropriate algebraic equations, and so we have to find out build time. Build time has to be seen. So let us see that if we are building a part in a machine, so I have made it a build in this. Take the example of selective laser sintering. There you have, say, some roller parameters are there: roller velocity, acceleration, delay time, recoating time. Means all that thing has to be seen. Machine chamber means how much it depends on this machine chamber also, that what is the area and what is the height of the chamber. Suppose you are making a very small component in a very big machine, naturally your build time will be more, because traverse will be more. And part geometry means has to be considered. Part geometry is very complex, but we follow some approach. So for example, one is called, say, bounding box. What is bounding box? That part may be very complicated, but in which size of the tube or parallelepiped it will fit. That means that is this one size of that cubical things or parallelepiped things. That what is the box that which will include that one. Then infill density, like in FDM, etc., that some portion is made porous type of thing, so that density also has to be considered. Support structure, that means there are overhanging elements in your part, they have to be supported. Then layer thickness, how much will be the layer thickness? More smaller the layer thickness, more maybe time. Surface area. Then you have to consider laser parameters also. What is the velocity of the laser? What is the diameter? Acceleration, deceleration of the laser. Then sometimes it moves with a rapid speed, scan spacing, then some time delay. Then you have to consider cooling time, heating time, solidification time. You have to do, if you want to estimate, then you may have to do some physics. You have to imply some physics heat transfer concept, like how much time it will take for solidification, then STL file conversion time, and this is pre and post processing time. Now, so like we are describing that how in selective laser sintering that cost can be estimated. We have got a laser source, and this is scanning mirror. It comes, and after that sintering is done here. This is the powder, but the powder is actually there is a powder delivery system by which the powder rises, then roller sends it here, and then after that sintering is done. And then this is movable powder bed. So one layer is complete, then it will come down, like that it happens. So it is, so we have to consider this thing. Suppose a roller is moving or a scanner is moving. In that case, you have to consider these type of things. Time for machine preparation involves machine setup, then warming up the cloth chamber, because some heating has to be done beforehand. Powder has to be preheated. So how much time will be required for preheating? If you have a specific heat and all these data, then it may not be very difficult for you to estimate, and further you can verify by actual experiments, because there may be some difference between your theoretical analysis and this one, because there are some heat losses that are not easily accounted. Then time for adding powder by the roller comes and it lays the powder, it makes the layer, and then time required for sintering, and then time for ending operation, that means cooling the chamber, etc. Now a typical roller will be like that. In a machine, a roller has picked up the velocity, it reaches this much velocity Vmax in time Vmax divided by acceleration. Then after that it moves with a constant speed, and then further it comes down. Okay, this type of velocity time diagram is there, and therefore you have to consider that time. So I have simple kinematics, but by that you have to consider all that type of things. Suppose total traverse is L divided by Vmax, but plus Vmax by AR. That means acceleration, that is pickup time plus time delay time TD into Hz by LT. Hz is the total height of the product and LT is one layer. So that means this operation will be done many times. So that means that time also has to be considered, and this has to be done. So then time required for sintering, it comprises two parts: times to scan, that means for actual sintering, and time to travel by the nozzle in the empty space of the bounding box at rapid velocity. That means if there is no space, then programming is done in such a way that it can move with a rapid speed. Suppose this is the width of the product and there is a line spacing, then of course the laser may be moving like this. It goes like this, then after that it goes upward, then again it goes in the another direction. In serpentine way it is moving, and this is this one. So if you know the movement profile, then it may be possible for you to estimate the cost. So we have done, depending on that laser diameter, and this is basically the spacing between the lasers, we have developed this expression based on the simple kinematics, and it is the total time of scan. You see that we are considering that factor also, that acceleration of the scanner. So Vs divided by Al. Okay, that part has to be this one. Now time to travel by the nozzle in the empty space of the bounding box, that means that time will be minimized. So suppose you are moving from here to here. Here there is powder, but in between there is empty space. You don't have to sinter. You can move with rapid space and you go like that. In that case, your velocity profile becomes like this. Here it is picking up, then going like this, constant, and after that it tries to reach at the peak, and it reaches this time, and then it comes down, and then after that it comes here. So that is when you have got a small empty space, you really do not attain the maximum speed possible. Maximum possible speed is say here, but you will be able to go up to this because this empty space is there. So for that purpose, you can develop one expression. These expressions are put here, but I am not going to derive these expressions here. In fact, all the details are in the paper, published paper, you can see that. And then suppose, but if you have got a big space, because your part may be hollow, in that case the profile will be like this. It will go here, it will go, after that it will attain the maximum velocity, then at rapid speed it will move at that place, and then after that it will go like this, and then after that again you have got the expressions for the time estimation. This we have derived, that kinematics equation, VR minus Vs square divided by this, all that expressions are there. And we can know that when the space is this one, because you calculate the magnitude, how much time it takes to travel. If it is less than a particular value, that means you cannot really attain final speed in that, and therefore it will be triangular. Otherwise it will be trapezoidal, this one. So overall time is calculated for a single part as T build is basically TMP, that means time required for machine preparation. This involves machine setup, warming up of the closed chamber, and some other preliminary operation. Then T operational time, here TAP, then T scan, and then T roller, and then TEO. And then it is like that. If you have got the number of parts, in that case, this type of cost will be divided. Okay, some elements will be divided by the number of elements because they are connected with the preparation time, and this is ending operation. And then scan time and rural time, this time will be not divided by the number of components. Okay, so you do the cost calculation based on the, if you have idea about the build time, then total cost will be material cost, operator cost, slicing cost, and then the overhead cost. And in which operator cost, slicing cost, and overhead cost, these costs have to be considered based on the salary of the operator and managerial staff. Total cost will be C material into material used, C slicing into time for design, then C operator plus C overhead will be added, and it will go in T build. That means build time calculation already you have done. That means how much time it takes to build the part, and this you multiply with the operator plus overhead, and then operator will do some post processing also. So C operator into post processing time is there. And when multiple parts are there, then the cost of an individual part is given by this one. That means material cost is okay, but this slicing cost gets divided into multiple parts, and similarly overhead cost also gets divided into this one, and individual cost will be there. And then you have to calculate that operator cost very carefully. You have to consider monthly salary, then working days in a month, and effective working hours in a day. And slicing cost means you have to consider nowadays, even for slicing purpose also, these things we don't purchase any software, but it is done on the cloud. So you have to give some license fee actually, and calculation is done this one. So annual slicing software cost is there. Then you divide by annual operating hours and monthly salary of the designer, and then effective cost. Then overhead means you in that you can include depreciation also. So in that you consider machine cost minus salvage value. How means after the machine has completed its life, in how much rupees it will be sold, and you divide it by machine life. And then plus annual maintenance cost will be added, annual factory rent will be added, and annual electricity charges will be also added. Now challenges in cost estimation. There are difficulties due to uncertainties, because there is sometimes some vagueness, and you don't know really how you should take into account. And cost estimation varies with business policies, production planning, place and time. So therefore, to tackle the uncertainty, there are many methods. You can use probability theory also, but I am proposing a fuzzy set based theory because it is very easy to implement. It deals with the uncertainty. It is able to deal with the imprecise and incomplete data. So little bit introduction about the fuzzy sets I will be telling. We are using fuzzy numbers. We say cost is not just suppose one number. I say that what is the cost of the product? You say that it is 1 lakh. In fuzzy approach, you will say no, it is a fuzzy number. That means 1 lakh is the most likely value, but it can vary between this range to that range. So it is basically the generalization of an interval number in which interval varies with the membership grade. What is the fuzzy number? Normally interval numbers, you should understand that we can have intervals. Suppose we say what is the cost of the product? So we can say the cost of product is, let us say we said 1 lakh. Now the cost of the product, somebody can say, okay, cost of the product is between 90,000 and 1,10,000. So this becomes an interval number where lower bound is 90,000 and upper bound is 1,10,000. Now in the fuzzy set, we make many intervals and we associate the membership grade. Like this value is there. So you are saying that this value of the parameter can be between here to here, and its membership grade is 0.5. That means something like 0.5 possibility is there, but it can be between this to this also. For that also 75% chance is there. That is why we are giving that, say, 0.75 membership grade. Okay. So question is that how do I make the fuzzy number? A simple and popular way is that for making any interval is to go to experts. Experts, they will say something, they will give idea. and membership grades assigned to an interval lies between 0 and 1. 0 indicates full non-membership and 1 indicates full membership. That means 1 means it is fully the member, that means, yeah, and 0 means it is not a member. Okay, I can have any set, like I have, suppose we say strong product and its membership grade is 1. That means definitely it is strong. If I say that its membership grade is 0, that means definitely it is not strong. If I say that membership grade is 0.5, that means you are dilemma. 50% chances are that it is strong and 50% you are telling it is not strong. So you are in confusion. Once you say that 0.8 membership grade, that means it is more likely to be, that strong, but you are not giving that 100% grade to that. Okay, it is 0.8. So like that, triangular fuzzy number I can make, in which I can use 0.5 membership to low estimate and high estimates of the parameter. That means suppose expert says that minimum cost will be 70,000, maximum it can go up to 1,20,000. So put 70,000 here, 1,20,000 here, but since he is giving two estimates, give weightage for it to 0.5. That means, but he will also tell most likely estimate that no, mostly the price will be 1 lakh. In that case, you give membership grade 1 because here he is almost sure. So like that you make the membership grade. And so identify the fuzzy, uncertain or imprecise variable in the problem. Then for each fuzzy variable, obtain the low, most likely and high estimate of the variable from the operator. Then construct a fuzzy membership function as shown in this figure. You construct and then estimate the cost by replacing deterministic variables as fuzzy variables, and then you carry out arithmetic operations because casting is mostly arithmetic. We don't require any knowledge of even algebra or other mathematics. Mostly by counting you can do. But here you have to use fuzzy arithmetic operation. So how do you do fuzzy arithmetic operation? That we will be describing. So first is that you convert it to fuzzy set based cost model, means you take some parameters as fuzzy, and then you have got these type of suppose triangles. Okay. So graphically I am explaining the addition process. Suppose your fuzzy number is A, and then you say that A is shown in a triangle form like this. That means A is that type of quantity where some expert has given its low estimate as 1 and high estimate as 4 and most likely is 2. It is unsymmetric number. Okay, fine. And then B is another number. So you do A plus B. So you get graphically like this. That means most likely got added, lower estimate got added with lower, and higher got added with the higher, and you again get a fuzzy number. If you do subtraction B minus A, then this is subtracted in the usual way. But here, lower estimate is subtracted from the higher estimate of this. Okay, that means you do in the reverse way. So typical fuzzy number at any membership grade is represented by A alpha. Suppose at any membership grade, you have got two intervals, that is A1 and A2 at any membership grade. Okay, although in a triangular membership, it is very easy because you have to do computations only at 0.5 and 1, and after that join a straight line. But in general, the concept is for any membership grade. And then what happens that if you do like that, then you can actually do the addition, that lower bound gets added with lower bound, upper bound gets added with the upper bound, and then you do that. Now here we consider some example of this one. Suppose I want to make a milling cutter by 3D printing, and another part is also typical part. So for that part we took the this data from the machine, and you can see this one, real thickness, maximum scan velocity 700 mm per second, scan spacing was 0.33 mm, and acceleration of the laser was 20,000 mm per second square. That means 20 meter per second, like that. And then we consider ratio of the part volume to the product volume. That means suppose we make a cube type of thing, then how much fraction of the part is there. Then time for adding powder by the roller, TEAP, that is also in second. Time for scanning. All the data you have to obtain. Total build time will be how much. So we compared and we did the operation. So first we did the build time analysis, and with our model, the build time came out to be 2.24 for one part, but in the literature someone else had done, so it was 2.29. So there is about 2.18% error because some assumptions are naturally there. And then another part here, my time came 1.52, another person's 1.436% error is there. And then we consider total build time. Part 1, it is 1.6, and if I make two components simultaneously, in that case it reduces and it is 0.85. And on the other hand, these people have given this way, so some difference is there. And then we detail up the cost estimate. So from operator we obtain the things. Material cost per kg, let us say it is $60, because for publishing the paper we converted everything to dollars. Otherwise actually we did in rupees. Monthly salary is this much, working days, slicing cost, and then we considered all that data. We have to collect the data. Machine cost, we considered this much. Machine life, we purchased, suppose we purchase a 3D printer, I consider that 8 years time is there, and salvage value was also taken. Annual factory, this one we have. But since you know many things, like suppose you say, sir, why you have taken 8 years life, so it can be less also. So that is why uncertainty means you want to know that how much sensitive cost is to what thing. So time delay, suppose it can be in second, somebody can say 5 seconds, somebody can say 7 seconds. Layer thickness 0.15, 0.21, like that we have taken. Monthly salary also may vary. Software cost, machine cost may also vary. Yearly maintenance cost may also vary. So many things are this one. In some cases you may be very sure, in some cases you may not be sure. So you have to, so this is the skill required only in implementing the fuzzy set based things. Now quantities in the machine chamber, then we get a result and we got a fuzzy number. So we got like that, cost came out to be $31, but low estimate is 28 and high estimate is 37. It looks very simple, but what is the advantage? That suppose you tell to a businessman, sir, the cost of the product is $31. No? Then he will not get the that idea. Instead, you tell that it is 31, but even if it is some bad things also happen, then it can be 37 maximum. So he want to get overall estimate. That is the difference between, because here we follow the scientific approach in academic institutions. We want to be very precise, but the life is not very simple. There are complications and people want to get subjective information also. So here I am giving that information, that suppose it is 26, but it can go 31. So he can make the strategy for worst case scenario and optimistic scenario. Part 2 is also varying between $10 to $15, and if we make two components, then it is between 6.26 to 9.4, like that it is happening. So graphically, if I am demonstrating by fuzzy numbers, so we give membership grade and we say total cost of part is this, and then total cost of part B is this, and total unit cost of part, if I make two quantities in a machine chamber, then the cost is this, and for another part it is like this. So now how do we interpret fuzzy cost? Now I have also employed one concept of fuzzy reliability. It is you can see more detail in the paper, but you have to see. But here we have employed one concept. Like suppose one operator person expert has said that this product will cost 1 lakh, and then also he says that maximum estimate is 1,20,000. So should we give equal weightage to 1 lakh and 1,20,000? Because 1 lakh means mostly it will be 1 lakh. So we have to wait. But he says, suppose he says okay, 0.8 membership grade means 80% chances are that it is 1,10,000. So that means I should give more weightage to that information. That means it is not only the interval is important, but at what membership grade that interval is there, that becomes important. So we say that in some cases, suppose he says most likely that you say membership grade 1. That means this information is more precise and there is no uncertainty. I say that, suppose I say that is this material strong? He said yes, its membership grade is 1. That means in the set of strong, its membership grade is 1. That means he is dead sure that it is strong. So entropy associated with this will be 0, means very minimum. We can say that it is 0. Here I am taking it like a 0 type of thing. That means it is this one. But moment he says, if he says 0.9, that means I will know that it has some confusion. And if he says that no, it is not strong, it is 0, then also I will say that there is no confusion. But once he said that it is 0.5, that means he is in more dilemma. That means because he is telling 50% this way or it is this way. So I can make any entropy function, but it should have that type of characteristic that that if it is 0, membership grade 0, that means it should be 0 because you are dead sure that it is not a member of the set. And if it is 1, then it should be 0. And if it is 0.5, then you should get maximum entropy. That means you should have this type of function. That is why DLUCA has long back they proposed this type of function, because it gives the maximum value at mu is equal to 0.5. And if you, as you go from 0.5 to 1, your entropy decreases. So entropy has been given, and uncertainty of the product is related to entropy. And then so this information we will make use of that. And then we also have, suppose we have got triangular membership function. Here the worst estimate is this. So at each particular membership grade, I can tell that what is the surety that this product will be fabricated in that much cost. Like at 0.5, we say if your money, if you have more money than H, naturally the product will be fabricated. So you can say possibility is 1. But if you are somewhere here, if your cost is really this and it is less than the limit, then you can say there is some chances. So we define a possibility index, that how much possibility is there that the product will be fabricated in a linear fashion. That suppose it is here, then we can say it is 0. And we develop this type of possibility index. And then we say reliability index is the possibility index and multiplied by the certainty of the estimate. Both the things we consider together, then therefore we make a product. That means it is possibility, that means I am 100% sure, but then that it will be made at that cost, at that membership grade, but that membership grade itself is uncertain. Suppose it is 0.5 membership grade, it has a lot of uncertainty. So therefore we multiply it like this and we get a reliability index. And overall reliability, we integrate this quantity between 0.5 to 1, and then it is, and we take the ideal case, and then we get the reliability. So that means that you get ultimately, you get what type of idea? Suppose you say part 1. So suppose you spend $37, then it is 100% reliability is there that it will be manufactured. If it is 35, then 99% reliability. Like that you get the data even for part 1 and you get it for part 2 also. So you get this one. So if you graphically plot it, you will appreciate that thing. Once you appreciate, I think this process, I am not sure that how much you have followed that concept of entropy, etc. But I am sure, because I am telling in the qualitative way, actual mathematics you can work with pen and paper, then you will really appreciate more. But what we will gain by studying these type of things, that idea you get, that suppose you have total cost of part, it is 37, etc., then it is 100. And you see that if slight cost money, you have slightly less money, then reliability decreases. first slowly, but then after that a rapid rate. Okay. Similarly, here also this type of behavior. So this is the typical behavior of any reliability thing, and you are getting the reliability data also. So in general, what I have explained you that are the three cost estimates that is most likely estimate evaluated from deterministic cost model. The low and high estimate from fuzzy cost estimate give a realistic value of the part. That means you are giving, and a method to estimate the reliability of the fuzzy cost is also introduced to guide production industries regarding the reasonable cost estimate. And concept of reliability can be further developed by considering reliability estimates as cumulative probability, and this will help in obtaining the expected value of manufacturing cost. Now, after that, I am going to tell you that how, once we have done a cost estimate, then how we can compare it with traditional manufacturing processes in the project. This part is also accepted for publication in one journal. So we compare it with injection molding. Suppose we are comparing any selective laser sintering based process with the injection molding. So here in this case, what I am doing, that suppose this is a schematic diagram of injection molding setup. You have got ejector pins which will eject the job. There is a screw and then support plate, and then this is cold plate and cavity plate, like that. Then if you want to do the cost modeling for injection molding, then we had to search a lot of literature here and there. Now you will understand the difficulties, that it is not so easy to do the cost estimation. It looks very simple that what is there in the cost estimate, that injection molding. Just see that in injection molding, you have got a mold. So there is a mold cost associated with that. Then material cost is there and processing cost is there. In the mold cost, there is a mold base cost. That means what is the size of the mold, etc. And then what is the manufacturing. Same mold will be there. Appearance wise, it may look similar, but one is precision based, other is not precision based. There will be huge difference in the cost. And processing cost means operator cost, labor cost, overhead cost, setup time, cycle time, number of components and production yield, all that type of things. So total cost estimation for molded part is, that means material cost, that is for each product what is the material. But then cost of the mold is divided by number of components, so divided by N, and then processing. Then material cost per part is actually that depending on that rho is that fraction of this one, means that how much fraction is the material and how much is the hollow. Based on that you calculate. Now you see cost of the mold is mold base cost and mold manufacturing cost. We saw a lot of papers, some papers written by Kalpak Jian also, whose book is very popular. But then his papers were also, there are a lot of papers in which he had done cost estimation. You see mold base cost I have taken like empirical type of relation. Now this itself you will ask that, sir, how it has come, what is that thing? I would say that yes, it is uncertain. That means there is it is not so easy that what will be the cost. They have used the empirical based, that means this is a height of that product and all that type of things, but it is not linearly varying with the height. Then processing cost also has to be considered, and then after that manufacturing time in hour for the ejector system. You have to make some ejector system that it will be ejected. They are giving this type of formula, that ME and the time for ejection time, making this one, and then AP to the power 0.5. Okay, so now after that manufacturing associated with geometric complexities of the part. So for that they are putting that xi plus x0 to the power 1.27 and measure of complexities for both the inner or outer surface. So they are considering that how many complexities are there. So complexities identification also has to be done. Total time for manufacturing one cavity and one pole is this one, and this is 0.085 and AP to the power 1.2. Then injection, estimation of injection and cooling time. This is also based on this Boothyard and Stelson's work. Injection time to fill the molten post plastic material into the cavity. This is the roughly this formula based on the fluid mechanics, this one, but we have taken coefficient of discharge. Then estimation of clamping forces. Now here we have got some C1 and C2 coefficients. This is simply the area into pressure. And then cooling time based on the ejection criteria of the mid-plane temperature of the part. That means we consider only mid-plane temperature, and here we compare the average temperature. So based on that, in fact, two formulae come. You can see the class references and you can get more details. So one gives some low estimate, other gives high estimate. So now what happens that now you can estimate. So since there are a lot of uncertainties, therefore here also we do a fuzzy set based type of thing, and we say that these costs are fuzzy and there are uncertainty, that estimate will come. But how do we compare that selective laser sintering with the injection molding? Suppose lower, most likely, and high estimate of a process, say SLS is less than the fuzzy cost of other processes, then no problem, then decision is easy. But in some cases, confusion may arise when some estimate is lower and some is higher. So we use the concept of fuzzy reliability. Now, reliability value at a particular cost can be considered as a cumulative probability that the part can be manufactured at that cost. Now, by knowing the cost at different values of reliability, one can know the probability distribution and evaluate the expected cost of manufacturing. This expected cost of manufacturing is the total area under the cost reliability from 0 to the cost corresponding to 100% reliability. An industry manufactures several quantities of a part as per the demand, where the sales and marketing department can estimate a probability distribution of demand. That means how much will be the demand when you compare this one. This is also important. If your demand is only small, then 3D printing cost may be more. So we have to get, and the demand distribution can also be different type. You can have uniform distribution, you can take normal distribution. Now example that suppose demand for a product varies from 50 to 100 quantities as per uniform distribution. Then roughly we can say the probability of each quantity is equal to 1 by 51. So we can find out the cost per quantity like that, 1 by 51 into unit cost by considering 50 quantity production, then 1 by 51 into unit cost by considering 51 quantities, then 1 by 51 into unit cost of 52 quantities, and similarly 1 by 51 into unit cost of 100 quantities, like that you add. In the normal distribution, the probability of demand for each quantity is different, and then the probability is given by this thing. Although it is for continuous variable, that means X is basically continuous, it can be decimal value also. But if your production quantity is very large, in that case you can consider it as a discrete also. Okay, so P50 and P51, like that you can consider this one, and you can find out the estimate of the probability. Then you illustrate, then you will see that for typical cases how we have obtained. We have details of different cost elements for injection molding. So in the injection molding, we have got this one, and then we have to consider material loss, because some materials get lost in the injection molding. And then we have machine setup time, okay, 2 hours. You see that machine setup time I have not taken here fuzzy. Why? Because you can of course take it fuzzy, but more the number of uncertain parameters you take, more there will be time required for computation. So if you are very sure about something, then it should not be taken as a fuzzy, it can be definite quantity. The number of cavities, like it is very certain that it is 1. Production yield is 0.9, that means 90%, that means 10% parts get wasted. that type of thing. Then monthly salary of mold operator, that is fuzzy, 270, 300, 330. Because what happens today, you employ somebody who is very experienced, so he's taking $330 dollars per month, let us say, and that person has left the job, another new person has joined, so he will take only 270. So like that, it will be fuzzy. Then monthly salary of labor is also like that. Working days in a month we have taken 25, effective working hours 7, but you can take these things have to be seen case to case. In some places that working days in a month may be not 25, but it may be 30 also, means or 27, 28, depending on how he wants to utilize. Then machine cost, we have taken 9,000, 10,000, and in between this one machine life we have taken definite 10 years, because if we have enough data, we are sure that it will be like 10 years, then it is okay. Otherwise, some difference may be there. Salvage value, then yearly maintenance cost, then annual factory rent has been taken, electricity hour, and then we have operating hours. Then we estimate the mold cost. We consider mold plate area as a fuzzy cavity and cold plate thickness. Also, we have taken like this, and then mold base cost. Then manufacturing time for ejector pin. Then manufacturing time for ejection system. Then number of surface segments. Like if there are more number of surface segments in a mold, then manufacturing cost will be more. So manufacturing time associated with geometric features of the part. Then manufacturing time for one cavity and core. Then manufacturing time for imparting surface finish to the part. Because if you have for that also there is a factor that has to be implied. If you want good surface finish, cost will be more. And average rate for mold manufacturing per hour, then mold manufacturing cost. Then total mold cost will be mold based plus mold manufacturing, and you get that as a fuzzy number. So we get this type of data. Then we take injection pressure, that means in Newton per meter square. 1 into 10 to the power 5 Newton per meter square is 1 atmospheric pressure approximately. So we require this much pressure, and depending on that, injection pressure becomes very high sometimes. Okay, and we get this one, but it may be fuzzy part volume. Then projected area, percentage increase in runner area, then prime force, and then injection power. So injection power also comes as a fuzzy number. We see that some cases there may be a lot of difference. And then injection time, then maximum wall thickness, thermal diffusivity, because cooling etc. will depend on that. It is mm per square. Injection temperature, then mold temperature, injection temperature, then cooling time, and mold resetting time, and cycle time. That means how much time in hour it is taken. So we get a variation of cost with quantities of part A. That means in a sales cost versus quantities at different membership grade. Suppose we see just the most likely value. There are some fluctuations like that, but in general, if you make after some time, if you make the mole quantities, doesn't matter. Means 3D printing cost is not that much dependent on the number of quantities. It is almost constant. So this is mu is equal to 1. That means most likely estimate. But according to other estimate, that means 0.8 membership grade, it can vary between this to this. And very crude estimate is that it can vary between this to this. That is very rough estimate, 0.5. And on the other hand, this injection molding cost, there is not much variation here because there are not much uncertain elements. But it goes like this, that mu is equal to 1 and mu is equal to 0.5, and this is what. But here it is clearly seen that it is very much dependent on the quantity of the production. So that means unless you make about, say suppose you have made 100 quantity, then naturally it will be, then it may be comparable, that even then at 100 quantity also, its cost is more than 3D printing. But if you make very less quantity, then injection molding cost will be very high because mold cost is very high. But if you make very large quantities, then the injection molding is cheaper compared to 3D printing. And similarly, here you have for part B also you get this type of phenomena. You see here somewhat uncertainty was less, and you get the cost between here to here, and here you have got cost of the injection molding. Here also clearly we see that if the quantities increase, then your cost decreases, and this will go. So now we compare by calculation. It is seen that up to 390 quantities of part A, selective laser sintering is a favorable process irrespective of the uncertainties. So that means if a company wants to decide that should it go for 3D printing or not, should it change the from injection molding to additive manufacturing, it should consider that what is the variety, how many varieties of the product it has to be made, what will be batch size. For example, in our simple case study, it came out that suppose you just make 390 quantities, then you can make by SLS, because this is here most likely cost is 23.38, here it is 23.91, here it is 18.99, low estimate 19.01, and here. So injection molding is always more up to 390 quantities. But suppose you make 406 quantities, then injection molding is favorable. Here that what happens that here cost of SLS, if I make more than 406 quantity, we see that here the most likely cost is 23.38. But in the selective laser sintering, the cost is, there is a typing mistake here. Here it is cost of injection molding in this side, right hand side, you correct it. This is because cost of SLS, cost of injection molding. Okay. So that means that this is cost. Then the part A, but the main thing is that suppose you are manufacturing between 390 to 406 quantity, then what happens? Then it requires careful consideration, and we find out the reliability of this one. So it is like that cost per quantity when the demand for part A varies from 390 to 406 quantities. If we consider uniform distribution of the demand, in that case, this is most likely estimate is here in SLS it is 23, and here it is this one, and normal distribution gives this much. Some difference is there between uniform distribution and normal distribution, but there is not much different. Expected cost of manufacturing for SLS comes out to be 23.67, and we get a reliability estimates for different values. That means this is the reliability and this is the cost, okay, of the product. Okay. So this is now when the quantity, now for part B, when the demand varies from 4,500 to 5,000, then this is the data, and we see that here is a high estimate, low estimate, and this one 3.13, 3.20, that means it is more 4.12, but the high estimate of this is high estimate is more. That means from so that means such type of scenarios may come. That suppose this table is showing that selective laser sintering, the cost is less than the most likely estimate is that mostly you will say that cost is less than the injection molding cost. However, because 3D printing has got a lot of uncertainties, so considering the uncertainty, the 3D printing is actually more costly. So that type of thing will come. You know that considering the uncertainty means that answers, this point has to be understood carefully, but in day-to-day life, these situations may come. That means in general, we say that this product is cheaper. But if you consider uncertainty, then the answer is no, that another product is this one. Is it not? That means cheaper. So it is of that type of thing. Means this happens in our day-to-day life also. That if I am giving offline lecture, maybe offline lecture may not be that much efficient, very difficult to accommodate so many participants. Even say Google Meet is much better. But if you consider uncertainty, that network may go and all those type of things, then your conclusion can be totally different. So all these type of things have to be seen even in the context of industry 4.0 also, because a lot of uncertain elements are there. So if you want to do any decision, you have to consider all the aspects together. That is the message I want to write here. So here, like I am telling that if we say upper estimate and then this is the reliability of the product, and we are saying that, so it is something like that, that if you most likely estimate point of view, SLS is better, 90% reliability, that means you can take some chance, it is this one. But if you want to consider worst case scenario 0.5, in that case injection molding is much better. That means now the manager has to understand, all the factory owner has to understand that can he take that much risk. Okay, if he wants to take the risk, then the conclusion will be different, and if he doesn't want to take risk, then conclusion will be different. So if he wants to be 100% sure reliability, he wants 100%, then you suggest him that you go for injection molding. But if he is ready for taking some chances, then you say that he can go for SLS. Okay. So in general, what I am telling that in this one, that selective laser process, sintering process, the cost per quantity decreases up to a certain limit, and then it becomes constant. Okay. So that means a little bit decrease is there, because suppose you have to utilize full build chamber. Like in one case study, in my build chamber, you can make maximum 18 product at a time. Now suppose you are not making 18 product, you are making only 5 product, naturally the cost will be more. But once I have done up to that type of thing, 18 product cost is this one. Even if you make 36 product also, then the cost will not be much different, because that chamber is fully utilized. Whereas in injection molding process, because mold is a very costly equipment, quantity, as the quantity increases, then the cost decreases. Okay, so these are the characteristics. If you take a small that 3D printer, very small size one, then even if you make 1 product or 2 product, it will not matter. That is why we go for now small type of machines, minute size of machines, so that they can be suitable for the customized products or personalized products actually. So that is why that we are going for small size machines, and then we can make this one, and 3D printing offers that type of advantage. But if you have really the mass production, suppose you have to produce say 10 lakh quantities, in that case you can take a big injection molding machine and you can do operations. And reliability estimates help in computing the expected cost of manufacturing. You can take variable demand also, that demand uncertainty can be considered. These type of things you can do. So cost estimation, that mostly I have told that cost estimation is actually important activity. I have used the fuzzy set approach to tackle the uncertainty, and so reliability estimates, that means probability based concepts helps in computing the expected cost of manufacturing, because if demand is probabilistic, that can be considered. Subjective decision making tool proposed in this work will guide the production engineers for choosing a favorable manufacturing process. There is always advantage of the subjective decision making process. You may ask that, sir, how you have constructed the membership grade, how you got the export estimate. There may be mistake in that, but then you are documenting each and everything. And if there is any mistake, then later on it can be carried also, because you are not doing in a ad hoc manner. You are just doing it in a proper systematic way, and there is this one. So either economical or reliable, or both economical and reliable processes can be considered. Methodology can be extended for other traditional processes, anything, for knowing up to what extent and in which scenarios it can compete with an AM process. So if you have 2-3 processes, you compare these based on the cost and say that which process is suitable. And while doing this thing, you will also know that which components are taking more time, more cost, and how we can cut the cost in those cases and which components are not very important and therefore not important to pay attention at this stage. So this one mostly I have told, sometime will be there for discussion. These are some references which I saw that a lot of things had to be seen. I will draw attention to some of this one. Boothroyd's book is very popular, but he written one book on product design for manufacture and assemble. Then there are, this one was 1972 paper for giving the entropy of fuzzy sets. Then cost sustainability, this one, CIRP journals, that some papers. And this one, cost estimation for rapid manufacturing for low to medium volume. That RAFO is doing a lot of work in this one, proceedings of mechanical engineer. This is a 2006 paper, 2013 paper of this type. And then Farm also is working on that, DT Farm. And then Gibson. And then these are this one, rapid metal tooling and in analysis of energy utilization. And then we have recently published one paper in 2019 which came in Journal of Mechanical Science and Technology. It is available. And recently another paper is also Journal of Advanced Manufacturing Systems in that, but one conference paper was also presented. In that only abstract was presented, but the papers are there. So with this, that I want to end my talk and open for the discussion. Okay. Yes. Okay. Yeah.
Participants, if you have any questions, you can post it on chat box.
Okay. I think one question is there, Abhilal.
Yes, sir. Yes, sir. Yes, sir.
Piyush Sharma has asked one question.
Yes, sir.
He says that how to do for startups actually in the beginning.
Yes,
okay. Sir. That is a good question, that startup, yes, precisely in that type of scenario, this type of methodology will be very useful, because startup, you have a lot of uncertainties actually. And you know that this may happen, so you have to consider various case scenarios, that in worst case it can go, in the best case it can go. My demand may be, say, maybe 1,000 product in a month, or it may be even 2,000. So all these data can be put, and then you can keep doing corrective action. That means don't make the same strategy for one complete year. You do some analysis and say that for 1 year your production plan is this, because this detail is there. Now, if you have everything in your computer, that means in Excel sheet or something, that information, then after that what you will be doing, you said that, okay, in 1 month my estimate was this much, but you know, here it happened, there is 30% error. So you can understand the reasons, and you can do the modifications for the remaining 11 months. So that way it has to be done. Okay. So that is this one. Okay. Now somebody is asking which method is better if I want to make something from ABS. So the answer will be not only on the material, but it will be dependent on many other factors. One may be production quantity. So production quantity is more, maybe injection molding is better. Then whether there is strength requirement or not, injection molding, because it is done with high injection pressure, so quality of the product is very good. You can increase the injection pressure and you will get a sound product, but you may not get the sound quality if you have doing. But sometimes we need some components only for decoration purpose, or they will just be some consumable item. In that case, that we can have this one. Okay. Very good question. Satish is asking that packaging and transportation are also how to be considered. Yes, we have not considered transportation and packaging, but these can be advantage. They can further lift the additive manufacturing, because in additive manufacturing you can argue that your transportation cost will be minimized, and in that case the additive manufacturing can be competitive, because in many scenarios additive manufacturing is still not competitive with respect to traditional one. But as you said, that this type of thing, that like nowadays also we are going to lockdown type of age, and transportation is also not taking place. Naturally, if you can fabricate something by 3D printing at your place, it is it will be very good actually. So that this point is can be considered by later on. Okay. Okay. So this is so I think these are the questions available, and other are just comments, is it not? So they no questions now. Available?
Yes, sir. Yes, sir.
So I think that most of the questions are covered actually, no? Is it not?
Yes, sir. There is no question on YouTube. Actually, on YouTube also participants are
Acha,
participating.
YouTube also. Okay, YouTube also they are participating. Acha, okay. But a good attendance, because now 239 people are there in this.
Yes, sir. Actually, there is a limit of 250 in this
250,
Google
yes.
Meet.
That's why you restricted, yes.
Yes, sir. Then if the participant increases, then we have to say that you should join the YouTube.
There is, I think, Rohit is there. He's in Department of Printing Technology. Can he tell me that printing technology means what they do there? Department of Printing Technology. He chairman and associate professor. Yes, Rohit. Hello, doctor. Yes, yeah.
Good morning.
Yeah, good morning. Yes.
Sir, yes, sir. I'm getting your question.
In your department, what are the activities actually?
Yes, sir. Basically, it is Department of Printing Technology, and where we are running 3 courses. One is BTech Printing Technology, one is BTech Packaging Technology, one is MTech Printing Technology, and other is PhD in Printing Technology.
Okay. Yes. Okay.
And if say printing, it is, sir, declared as the second biggest industry after automobile industry throughout the country and throughout the world.
Yes.
And printing is declared as the greatest invention related to mankind by Time Magazine, USA. And the spectrum of Time Magazine is very well known to all of us.
Okay.
And the father of printing, Sir Johannes Gutenberg, he is declared as the man of millennium again by Time Magazine.
Okay.
And every aspect, it is printing is there in from morning till evening, or say day night, or say day hours. It is there in human life. We cannot survive without printing and without packaging. And because you are,
packaging are really this one important areas, na. Yeah, because once I went to that Confederation of Industries also, and they told me that packaging and printing is their heart area, and they wanted to do something. So good to know that you are from there and you have joined.
Yes. Thank you, sir. Thanks.
Okay. Yes. Okay. Okay. So Dr. Mishra.
Yes, sir.
Because now other speaker will come, so time is also, I think.
Yes, sir. Yes, sir. Professor Dinesh Kumar from IIT Roorkee is going to join us. Yes, sir. So I think the participants have really enjoyed the session and came to know about the various challenges exist in different component of the industry, and what are the challenges actually occurring during the upgrade it into industry 4.0 ready. So thank you, sir, for taking your time from your busy schedule and sharing your research work with the participants. Thank you, sir. Thanks a lot, sir.
Thank you, sir.
Thank you. Hello.
दिलबाग सर,
मिश्रा सर, सुनाई दे रही है मेरी आवाज?
थोड़ा कम आ रही है. You can use some headphone or mic, I think.
Hello.
Now it is fine.
Okay.
I think.
Okay. So we will start with soon start with Professor Dinesh Kumar, and we are trying to connect.
Dear participant, please be with us. Professor Dinesh Kumar will join us in very short time. So be with us. We will start the session as soon as he joins us. I think sir has joined. Dilbag sir?
Yes, sir has joined. I have talked to him.
Now I am handing it over to you.
1 minute. Okay. माइक सर माइक ऑन कर दो अपना ना। हाँ आ गया। नहीं आपकी आवाज नहीं सुनाई दे रही है सर मुझे ना। हेलो।
So your mic is mute, sir.
माइक इज म्यूट सर। रेड कलर का दिखाई दे रहा होगा सर नीचे ना उसको।
Okay.
हाँ
Yes, fine sir.
Okay.
Fine, sir, fine.
Yes sir.
Screen is visible?
Yes sir.
मेरे को नहीं आई है। मेरी कहीं।
हाँ। Visible sir, visible. Yes, it is visible sir.
You okay now?
Sir, let me introduce sir first.
Should I start?
Sir, 1 minute sir. Hello.
Okay.
So, dear participants, we have with us Professor Dinesh Kumar from IIT Roorkee. On the behalf of organizing team, I welcome you, sir. And Professor Dinesh Kumar is eminent academician, researcher, and administrator in the field of industrial engineering, operational management, reliability and maintenance, process planning and optimization, modeling and simulation, and supply chain management. He is having teaching learning experience of more than 35 years. He has guided nearly 30 doctorates and several master theses and graduation projects. He has published nearly 300 research articles in the renowned journals, conferences of repute and recognized book series. He is ranked among the top 20 Indian leading academician publishing in supply chain management by the Institute of Transport Logistics, Dortmund University, Institute of Supply Chain and Network Management. He is recipient of Outstanding Paper Award, winner at the Literary Network Award of Excellence 2013 by Emerald. Professor Dinesh has handled several research and consultancy projects aimed to serve the societal needs in his area of expertise. He has handled several administrative responsibilities, which include head of the department, coordinator, and chairman of various programs. Furthermore, he is enlisted as the POG member of academic committees of various technical universities, and member of various professional renowned societies. So here we have Professor Dinesh Kumar. and he's going to give his talk on IoT and operation management. So thank you, sir. Thank you, sir, for joining us. So it is over to you.
Thank you, Dr. Dilbag, that you have given me this opportunity to share my views with the participants. The topic of discussion today is IoT and operation management. And as probably most of the people are talking about the Industry 4.0 and IoT and digital transformations, because these are the hottest buzzword nowadays, and it is very, you say, needed in the industry because we need, you say, the analysis of the data for the continuous growth of the industry. So we'll discuss today how we can get the data, or what are the different areas where the data are to be needed for the overall improvement of, or you say, for the operations and for the improvement in the operations. So some of the issues which we'll discuss: key issues of the operation management, key decision of the operation management, parameters which will contribute to the industrial operations, what is IoT and what is IIoT, and their importance in the industry, their imperative for the success, and some factors which contributes to optimize the effects. Probably you have seen this figure is a very, you say, connecting figure which indicates how the different departments of the industry are interrelated. We have a number of departments like production, the main department, and where you say the personnel department, purchasing department, engineering department, distribution section is there for transportation of the, and this you say produced products are to be sold in the market, so marketing also is associated with that, and the associated department are the finance and the accounting. In the requirement of what we need from the industry, we want to produce a product which must be a perfect product, which we call should be a quality product, cost-effective product, defect-free product, environment-friendly product, and product from the available resources. So I have added this point, products from the available resources, because the company has a limited, you say, resources, man, machine, material, and manpower, and the company has to do all the activities with the available resources. So this is the figure I have given for considering what is the meaning of a perfect product. Perfect product in the mind of the customer, or with the need of the customer, that what the customer wants and what the customer expects, for which he has paid the money. So the natural product, for example, we say a mango, now it is a flower, and similarly if we say a mango, the mango which you say we get from the tree is a perfect, which you say satisfy the customer needs. So here also we have shown you a flower, rose. Just see the combination of the color combination, the size of the leaves, and you say the other parameters which indicates that this is a complete and a perfect product. You cannot find any defects in the product produced naturally. Okay, this is another type of rose. You just see the color combination. Now in the industry, we just say the resources are to be converted into the useful product. Either we have a goods to be, you say, physical product, or we have to provide the service. And you say in the conversion process, we have, in the starting and we have say some adjustment are to be needed to change, you say, the process of conversion depending upon our requirement, depending upon the changes we want to make, and certain fluctuations are there which are to be adjusted. Okay, and then we get the feedback also from the, when you say the product will be in the hand of the customer, then how it behaves, or how you say the customer are satisfied with the product, then we have to change our, you say, process of producing. Just have a look of the production and operation management in the industry, that is product. We have to define the product. We have to find out what is the production capabilities we have, then what is the production schedule we have, and then what will be the production performance, that is the product produced or product you say the capabilities we have, how we say perform the different operations in the industry. So just have a look of this: production resource management, product definition management. Then in the product schedules we have detailed production schedules, that is how much time each machine will take to you say add the values, then how it will be transferred from one machine to another machine, and from final finished product how it will be transferred to the store. And then you say production performance, you say production tracking, you say how it will be tracked, monitored, the value, the quality, and how the data from each machine are to be collected. What data we just will discuss. What are the different types of data which are to be collected and then to be analyzed so that the necessary changes can be made. So just have a look, that is operation management we say consisting of the planning, scheduling and control of the activities that transform inputs into finished goods and services, just we have seen with the figure. The various activities related to the operation management are job design, scheduling, material management, capacity management, facilities management and quality management. So the operations are to be synchronized with strategic planning of the company, as management of operations determines the task and technology needed to fulfill the strategic objectives. It is to decide how to acquire the resources, means the raw material, the manpower, how we acquire the resources, how we design the facilities, and how we measure the service delivery to reach the company intended target. Now the company intended target, when we say each company has the objective of converting the finished product, so raw material, into finished product, and the objective is to produce maximum, and then the target is to maximize the profit. So profit will be maximized only when we will produce maximum number of products. Okay, so then we say the various activities which are the scope of the operation management are forecasting. We have to forecast how many units are to be produced when. Capacity planning means what capacity we have and how we plan our capacity, available capacity, and required capacity. Then how we schedule the products to be flown to flow into the system. Managing inventories means the raw material, the inventory of the raw material and inventory of the finished products. Then the quality, assuring quality means the required quality or the defined quality, how we will achieve that quality and how we will assure the customer that is whatever we have, given that this quality will give you, that we have supplied. Then motivating employees. Employees is a big source in the company, and a continuous motivation is required for giving the required output, for maintaining the good quality, means involvement in the industry. Then deciding where to locate the facilities. If we say in a country also, where the facilities are to be located is to be near to the market or near to the resources. Both have its implication. When you say it is near to the resources, then the transport of the raw material will be easily available, and the transportation cost of the raw material, or the inventory, you have to keep low for the raw material. And if you are locating near to the market, then means it will be easy to access the market, to supply in the market as per the customer need, or you can make the changes as per the customer need. And the supply chain management also is a part of the operation management activity, where we will supply we'll take supply in and supply out. We'll just have a look of this figure. Supply chain, in the manufacturing example, where we say upstream and downstream. Upstream, we say that is the oil company. The example is given by the oil company, that is from the different sources. You say from the field, the oil will come to the refinery, and then it will be processed and then will be supplied to the consumer. So that is in the industry, we say the collection of the raw material from the different areas, from the different locations, and then bring to the factory location, where it will be converted into the final finished product, and then will be supplied to the store, kept in the store, and then supplied from the store to the different locations where it will be, will be distributed to the number of consumers or number of retailers from where the final users will buy it. Okay. Okay. So then we say why we have to study the operation management. We say here every aspect of business affects or is affected by the operation, because when we are doing the operation, whatever activity we are doing, or you say the requirement, will be affected by how we are converting, how we are doing the process. So in service sector also, many services are also closely related with their mode of operation. For example, you say the financial services, means how the financial aspect, you say, are to be processed. You say the requirement of money, means how you get the money from the different sources, from the bank or from other, you say, the things, and then how it flows. Because the financial services is very important in the industry. Because the revenue will be, you say, only generated when the product is finally sold to the final user. Otherwise, you say from the purchase of the raw material to the production and then keeping it in the stores, you have to invest the money, because you have to pay so many for so many things, and so the investment will continue till the finished product will be sold to the final user. Okay. Then marketing service. So how we'll operate the market, how we run the market, or how we analyze the market for selling of the product. Okay. Accounting services means the accounting is to be maintained for, you say, inflow and outflow of money. Information services is very important because the flow of raw material, flow of, you say, the process, flow of, you say, the fund. So all are important, because for every information, the actions will be accordingly. So we observe significantly amount of interactions and collaborations amongst the functional areas. These provide an excellent vehicle for the growth of the vehicle. Okay. Business operations overlooked. Just have a look, that is how the different things, operations, marketing and finance, these are the three important attributes of the industry, which how they are connected and how they affect the industry operations. Now another connectivity of the different parameters or different attributes in the industry which are related to the operation management. First we are saying purchasing, we are starting from the purchasing logistics, economics, accounting, strategy, marketing, engineering, industrial engineering, information management and organization behavior. Just have a look the interactions or connectivity of the operation management with all these strategies, okay, and how we say the performance measurement and planning will affect, that is the operation of the industry. Okay, so all these attributes we say are the part of the operation management. The interfaces of the operations, just another look of the figure where we are saying that just if you see the first figure where we have said the resources are to be converted into the useful product or the service. And we have given all these, you say, parameters which affects in the conversion process. Okay. So here, from the industrial point of view, we are saying the legal point, management information system, personal, public relations, maintenance, industrial engineering, all are, you say, affects the performance of this industry. Now, what is the role of an operation manager? Operation manager has to identify the customer needs and convert them into a specific product or service, product to be produced in a given time. That is also very important, that the number of products are to be produced in a given period of time and then delivered to the place of the customer. Then do backward working to identify raw material, like how much raw material is required for producing the total number of products we want to supply. Identify the internal or external vendors to create supply chain for raw material, to finished goods between vendors, production facilities and the customer. The various operation decisions includes what resources are needed and in what quantity. When will each resource be needed? When should the work be scheduled? When should material and other supplies be ordered? Where will the work be done? How will the product or service be designed? How will the work be done, and how will the resources be allocated? And who will do this? Is related to the manpower. Who will do the work? This is very important aspect. Who will do the work? That is matching of the people with the machine. That is when we are talking about the matching of the person with the machine, means the skill of the person is very important. Whether he will be able to operate that machine, will produce the required quality of product by using that machine, that is. So, if, for example, we say if the person is not available, then who will do the work? Who will be replaced by, in the case of the absent or not available, that person. Now, various performance parameters which we are saying are to be monitored or to be seen. Profitability is to be seen is the important part. That is, if the profit will not be there, then the company will not be able to run. And to see the effectiveness of the machine, effectiveness of the manpower, effectiveness of the operation. Efficiency, when we say the efficiency of the machine, efficiency of the manpower. Cycle time, we say the total time from the raw material to the finished product. Cycle time, we say a production cycle time, and the total cycle time also we can say. We can divide into two types of cycle time. Production cycle time and the total conversion cycle time, we say. The quality, the required quality to be produced, quality of the machine, quality of the process, and the manpower, or you say the person or those who are producing the quality product. Quality of work life, that is where the people are working. The quality of the workplace, we say, where the people are working, because it affects the efficiency of the people. It affects the efficiency of the, you say, manpower or the labor working in the system. Means the innovations mean adding of the new features. Adding in the new features of in the product. For example, we say a car manufacturing company. If you see a particular brand of the car, let us say Maruti, a particular segment of the car, let's say price segment, say 4 lakh segment of car. So in 4 lakh rupees, you will try to find out the maximum features available in the car. So that is the part of the innovations, how you say the different features or number of features are to be added at the minimum cost in the same segment, so that say the customer wants more number of, you say, features at the same price. Then utilization, how you say utilization means when the product will be in the market or in the hand of the customer, then how it will be utilized. So productivity, as we say, is the output to the input. So it is related with number of items or number of products produced with the available resources. Okay. So again, as we have mentioned, the role of industrial engineer also to interconnect the people, processes, and technology, and the objective is to accomplish the organization goal. And organization goal is the maximum production. Organization goal is the maximum profit. So various areas where the industry has to work: the general management, production systems, factory management, maintenance management, production control, relation with labor, and we have to check the labor laws also, trade supervision, policy of strategic manufacturing, system analysis, productivity analysis, cost control, materials planning. Okay, so all these are the areas where the people are working, and we have different departments. All we have a separate department, and then now we in manufacturing where to do better. We have to save time. Means how we can say we can introduce a machine which will do the work in a minimum time. Okay, we improve the working conditions so that we can improve the efficiency of the people. A good environment will provide, will give a boost up to the worker, that is a better environment. Improve the quality. If we will improve the quality, it will generate a trust among the people, among the customer, that this brand is of a good quality, and definitely they will be ready to pay for that. Now, save money. When we say save money, means we have to reduce the production cost. So if we are not able to increase the product, there are two things. When we say the profit is the revenue minus the cost. When we say the revenue is when the product will be finally sold to the user, and the cost price will be at which the product will be produced. So when we say save money where the save money will be how we can redesign our process, or you say our facilities, so that we can reduce the production cost. Reduce the production cost, or with the improved productivity means improve the number of products to be produced with the same facilities. Okay, and then improve the customer satisfaction. Customer satisfaction means whatever quality we have promised, we are delivering to the customer. Then the customer, and if you say possible, will you say reduce the price, final price you say, or competitive price when we say. Now the sector of information flows, because from the industry to the customer, now we are confined to the limited area from industry to the customer. So from the industry to the customer, we have three things, that is where the flow will be there. First we'll say the product flow. Product will flow from the industry to the customer, but the unserviceable product will flow back from the customer to the industry. The fund will flow from customer to industry, but if you say unserviceable product will be, you say, returned back to the industry, then the fund will be, or money will be given to the customer for that. Okay, the information will flow both ways, because when the industry will say is supplying the product, it will give a manual that how to operate, what are the conditions to operate. So these are the instructions to operate, to use the product, that should be followed by the customer. But you say the feedback, the industry has to get the feedback how the product has performed in the field, how much you say customer has been satisfied with each product. So these are the feedback which will be received from the customer by the industry, and accordingly the industry will change its, so you say, program, strategy, to modify the things and do better. So key issues for operation managers, that is a part of whatever I have discussed: economic conditions, innovations, quality problems, risk management, and competing in a global economy. And today trend in business, we say internet, e-commerce, e-business, management technology, globalization, outsourcing, agility, and ethical behavior. These are some of the trends which are going. We have to check these things also when we are say in the industry or we are producing something. So now the places from where we have to collect the data to be collected in the industry, the data to be collected by the operation managers are based upon the business problems and company. Some are cycle time, individual workers, shift, facility, productivity, idle time versus active time, time between order submission and commencing of orders, time spent on employees on each job daily, weekly and monthly, post per job, time spent searching for tools, data translation for operations improvement, that is IoT solutions. We say is an IoT solution. Data are useful when used in decision making, for example, to know that how productive are our workers. Measures their time spent, how much time they have spent for each job on each machine or with certain parts of the material related to the job, equip workers with materials with IoT devices. So if you say the workers are equipped with the IoT devices, then he can track. You can track and he can record the data. It helps to track, analyze and make the changes. Other areas of data collection, resource utilization, how much resources have been utilized. So we say in a real-time energy profiles to detect off-hours consumptions, optimize manufacturing production schedules, identify anomalies. So these are some of the things where the data are to be needed. Benchmarking for similar pieces or comparable location, detect systems not functioning properly, to detect hidden operational efficiencies and energy waste. Predictive maintenance, data for preventive and predictive maintenance, alert for service, efficient production, technological and organizational changes to optimize manufacturing processes and the systems running the plant, that is outputs with more efficient energy usage. Behavioral changes, energy consumption data to diminish wasteful habits in their team and instill behavior changes in the corporate culture. Management models to align with corporate social responsibility goal and lean manufacturing, Six Sigma or other management tools, tracking return on investments. So these are some of the areas where we have to collect the data, information, so that we can analyze them and we can make the changes. The IoT role in successful business, we say data collection is based upon technology. Presently, gathering data from the operational workflow by leading companies and using them in decision making is by a process which we refer as IoT, or industrial IoT also when used for industrial application. When physical assets or workers are equipped with IoT devices, data on their environment and locations can be known, analyzed and cross-referenced with other sources of information like ERP system, cloud services, etc. That is, any action, any movement or the process which we are using can be recorded and can be used to optimize any business operations. True operational efficiency will become a reality when we are using the IoT. So the IoT enabled areas, we are saying digital connected factories, IoT enabled machinery, transmit operational information to equipment manufacturers and to field engineers. Operations managers can remotely manage the factory with process automation and optimization. Digitally connected establishment, better line of command, identify key result areas. So you say, when you say we have the information system where what work is going on, how the work is going on. So all these information nowadays you can get on your computer screen. So when you say all are connected with the information. Data are, you say you can check the data at any moment of time, because for real time data are collected and you say transferred immediately. So that is the use of the IoT tech devices. Okay. Facility management means each facility is located with IoT sensors. We call them IoT sensor machines, which will give you because when we say with the continuous usage of the machine, the condition of the machine may deteriorate. So you say the condition based alert will give, when you say it is giving the condition, any sound, unusual vibration, if it is there, then definitely an alert will be there that there are some problems in the machine. Accordingly, the action will be initiated. So this will reduce the cost, this will eliminate the machine downtime and will increase the operational efficiency. Production flow monitoring means how we say the raw material is flowing in the process. How you say the raw material is coming from the different sources in the process, in the factory side, and then how it is flowing in the industry from one machine to another machine. Then after you say finishing of producing the finished product, how the finished product is flowing from the factory side to the store, and then from the store to the different locations where they are to be sold finally. The close monitoring highlights the lag in production, where lag in productions are there, which can eliminate, which we say eliminating waste and unnecessary work in progress inventory. Okay. So more areas we have. Inventory management means we can check the inventory, because we will have the information how much inventory we have. IoT monitored events across a supply chain. The inventory can be tracked and traced globally. Means if the industry is a multinational company, then from the different countries, because some part may be manufactured at one place, another part may be manufactured at another place, in the same country or maybe in different country, then they have to be supplied to the main where the assembly will be there. Okay. For example, we say a BMW car. Okay. So BMW car, a plant in India where we are doing the assembly of the number of components, and these components are to be brought from the different locations. Maybe some part they are manufacturing in China, some part they are manufacturing in in other country. So from all locations, the different components will reach to the main factory site where they will be assembled to the final finished product. So this provides managers with realistic estimates of the available material, work in progress, and estimate the arrival time of new material, optimize supply, and reduce shear cost in the value chain. Plant safety and security is also very important. Worker safety. Worker safety, monitoring the key performance indicators related to the health and safety, because this is, you say, a binding, the government laws has to be followed, and the World Health Organization also will have a key performance indicators which they have, benchmark has been given for the workers' health and safety, like the number of injuries and illness rates, near misses, how many misses has been done, short and long term absentees, vehicle incidents, and property damage or loss during the daily operation. This can be monitored. Quality control means the product data, third party syndicated data from various stages of a product cycle, like composition of raw material, working environments, waste, the impact of transportation, etc. on the final products. Moreover, when used with final product, data for customer sentiments with product usage. So this is last part is data for customer sentiment with product. When the customer is using the product, then how he is reacting with the performance of the product, that also can be, you say, if you say like the people are giving their feedback. So on net you check the views of the people, that how the product has behaved when used by the different type of people. So they give their feedback, and that will help the company to improve the product. Okay. So any deficiency or the drawback in the product operation, product performance, when it is in the hand of the customer, will be received by the company, and accordingly the actions will be initiated by the top management of the company. So packaging optimization means data about the usage, handling pattern from multiple customers, trace product deteriorations during transit, impact of weather, road and other environment variables on the product. So this part I have included specifically considering that when you say the product, here we are talking about the finished product. When the finished product will be supplied from the company location to the different destination, the mode of transport, how it will be transported, what is the size of, you say, packet, how they will be kept, how they will be loaded and then will be unloaded at different locations, and again they will be loaded and then unloaded at the different location. For example, we say the glass items or the breakable item. So probably you have seen on the packet or the carton it is written handle with care. Handle, when it is written handle with care, so you have to check how the packaging has been done. If the packaging will not be done properly, then even if you handle it with care, then there will be some brokerage will be there. So means, so you say the packaging, how the packaging will be done, then so it should be easy to transfer it from one place to another. Similarly, you can say the transport of the TV or other, you say, appliances, where we have a delegation, means a delegate part, and if they are not be transferred, you say, then the deteriorations may occur. When you say the customer will not ask about where, how deteriorations occur or how it, why it is not giving. He wants a perfect product only. Logistic and supply chain optimizations. So IIoT access the real-time supply chain information by tracking materials, equipment and products as they move through the supply chain. IoT role and its applications. IoT is a system of, as we have said, now we can check. The IoT is a system of interrelated computing devices, mechanical and digital machines, objects, animals or people, provided with unique identifier and the ability to transfer data over a network without need of human to human or human to computer interaction. It is an information network of physical objects where we have the sensor, here we have machines, car, building and other items to allow interactions and cooperation among these objects. A smart thermostat has sensors in multiple rooms and connects to your phones and the internet to allow you extended control over the temperature. Another example I can give you, that is, you will have a device on your car which will, you say, give the information on your mobile that where your car is located. So if anybody will, you say, try to, you say, to carry it, then automatically your mobile will, there will be an alert on your mobile that your car has been, the effort has been made to take away of your car. So that will be the things nowadays, the use of the IoT devices. You say IoT extends well into commercial and municipal uses as well, and can include everything from building temperature control systems to sensor enabled trucks to digital manufacturing control system. IoT is changing the landscape of how business gather and analyze the data across nearly every in every industry and sectors, including the manufacturing. IoT for manufacturing can harness the data from machine, means from each machine we collect the data, and from in each equipment we get the information, that is where the raw material or the, you say, semi-finished material has reached to it, how much time it has taken, and where it has been released from the machine, and how much time you say what is the quality of the or the features of the features which has been produced or done, or you say the actions which has been say by the machine. So to transform the processes and system of the modern factory environment, apart from manufacturing risk and competitors value speed and innovations to affect client, the transformations brings by IoT. So just have a look, that is where the work is being done by automatically. So we say the IoT, the use of IoT devices is converting the movement of the product and automatic working of the the different robots with the movement of the material. Okay. Different layers of IoT are application layer, computational layer, transmission layer, and the perception layers. The perception layer, we say the goal is to enable objects with a sense of vision, touch, smell, hearing, and then that you have observed this is the object, some object is there of the required size. So when we say the perception layer will recognize the object. Okay. Then the goal, the transmission layer, the goal is to transmit the information to the upper layer. So that information is transmitted to the upper layer that some object, that the required object has been reached to the destination. Then it will, the computational layer will the describe means of receiving data, how the data or what data will be received. Means the depending upon the feature, depending upon the type of data we want to receive, we will collect the information from the product or from the object, processing data, making decision data, and delivering. Then we have to take the decision and then deliver this decision to the next application layer. Application layer, it provides the tactical understanding by using the information collected and transmitting from the lower edge. Okay. So these are some of the IoT devices to collect the information, which are depending upon the type of machine, type of things where you want to use the devices. Accordingly, the devices may be designed and will be located at the place. So the various applications of the IoT will be transportation, healthcare, smart homes, and the industrial environment. And the IoT is used to collect and handle the huge amount of data that is required by the artificial intelligence algorithm. These algorithms convert the data into useful, actionable results to be implemented by the IoT devices. For the industrial, as I have said, the IoT and IIoT. IIoT for industrial environment we use the IIoT, and IoT for the commercial applications we use the IoT. Okay. So IIoT has grown from the variety of technology and their interconnections in manufacturing. The first attempt to create a network of things was started in 1970s, named as computer integrated manufacturing. So the difference between the term IIoT and Industry 4.0 mainly concerned the stakeholders, geographical focus, and the representation. IIoT semantically describes a technology movement, while Industry 4.0 is associated with the expected economic impact. That is to say, IIoT leads the Industry 4.0. The term industrial IoT involves when IT is integrated with industrial automation and control system. IoT visions of the world is one when smart connected assets operates as part of large systems that make up the smart manufacturing enterprises. IoT brings the concept of Internet of Things to the enterprise level. Means the IoT to the industrial level, then we have given this word IIoT. So we are using this word Internet of Things essentially enables us to connect things of the Internet and to the network that uses internet technology, these things or items can exchange information between them and transmit data to other devices and systems. They can usually also receive the data, means transmit the data and they receive the data. The information they share can be about objects to which they are attached and the environment they are in, through sensors that come in many shapes for different parameters. So we say, as I have shown you, the trackers of some shape, but they are of varying shape and size depending upon what parameters or what data you want to collect from which machine. Smart devices and machines can also share information about their internal state. So means some of the chip may be there on the machine or inside the machine, which will give the information related to the operation of the machine, alert of the working of the machine, like that. Okay. The Internet of Things is changing the landscape of the how business gathers, analyze the data across nearly every industry and sector, including manufacturing. I heard this is repeat of the previous. The fourth wave industry, this is also not needed. Now the IoT in manufacturing, the different places where the IoT will be used. First is digitize and optimize the manufacturing processes. You say if each machine will be connected with IoT devices, so that the data will be received and transmitted, so say and exchange data. In manufacturing, the IoT connects assets to processes, systems and people. Means when you say the devices will be, each machine will be with the IoT devices, will give the information to, you say, to the system manager, to the people. That is, and it also gives the information that who has produced what. Okay, related to the person also, it will have the information of the person also, that during which time which person has worked on the machine. This enables better integrations of plant processes, achieving higher level of productivity and taking manufacturing to the next level of transformation. Means next level of transformations can be done with the available, you say, information. Intelligent assets and equipment. When referring to an intelligent assets or piece of equipment, by enabling these assets with IoT sensors. So we can say the smart equipment, smart machines, where they are with the IoT sensors and cognitive capabilities. They can sense, communicate, and self-diagnose issues in order to optimize the performance and reduce the downtime. Means how they will optimize the performance means any deficiency in any part of the work will give an alert, and accordingly, so that the actions can be initiated immediately, can be before the start of any before the start of any problem, the action can be initiated. And reduce downtime means that when the downtime will be reduced, then we say the failures or you say non-productive time will not have, or will be able to reduce the non-productive time. Using intelligent assets and equipment, it is possible to prevent production delays and improve production in line performance. Means we can prevent the production delays. Means where we have deficiencies of, or say maybe because of the man deficiency, man inefficiency, or machine efficiency, or means the delay in transporting the material, any of the things which because of that we say delays are possible. We can reduce them, we can eliminate them, the delays, possible delays, and improve the production line performance. So we say, as we have indicated the performance parameters, so the production line performance we can definitely improve. Reduce equipment downtime, as I have indicated, and increase the process efficiency. Process efficiency definitely, when we have every information we have, then means that we can take quick decisions related to every aspects. Expedite equipment repair, when we'll know in advance or when we'll have an alert that this is related to the equipment performance or equipment operation, or there is a condition about the equipment, then accordingly we can plan that when this machine will go for repair or how much time this machine will be in repair, and then who will do this operation of repair, so that quickly we can bring back the machine into operation. Third is cognitive process and operation. The concept of a cognitive process lies in the fundamental ability to take existing data and analyze it to drive decisions around improved operations, quality and safety. By analyzing both structured data being collected in database and unstructured data such as photos or videos, footages, it is possible to bring more certainty to decision making and vision. So that with all these things, because you have the information, data given by the machine, data given by the tracker, and the videos and photos we have, so you can check who has done the mistake, what mistake has been done at what time. So then you can take the action in advance, expedite the service call and repair and reduce the warranty cost, improve the quality and yield due to improved quality practices. Smarter resources and utilization, optimizing resources, whether it will be people, energy or knowledge, is critical to keep cost low and improving overall engagement and productivity level. So in the industry, because as I have said, we are using the different resources. For example, we say any of the product. Just as I have given you the example of the automobile industry, where in the main unit we are assembling only the number of components, and these components are produced in the different, you say, companies or different ancillaries of the company. So from different sources, from different locations, the required number of each part is brought to the factory site. So when how much is to be brought by which process. So when you have the data information, you say all information you have, then automatic process will be, that is the automatic, you say, transfer of the information will be there, and automatic release of the material will be this much. Using IoT and cognitive insights, it's possible to utilize inputs like geolocation data, usage data, individual data and environmental conditions combined with analytics to improve worker safety and gain better workforce management, increase worker productivity and expertise, reduce energy consumption of your facilities and buildings. So just it's a repetition of the figure. So there are different phases of operation management, as I have indicated. When it is well connected, then you say the data will be transferred from one place to another place, and then you can monitor each of the machine. Means IoT-enabled machinery can transmit the operation information to the partners like original equipment manufacturers and to the field engineers. This will enable the operation managers and factory heads to remotely manage the factory units and take advantage of process automation and optimization. With digitally connected grids helps to establish a better line of command by manager. Facility management. So this is also, we say, the facility you can manage in a better way. Production flow monitoring, monitoring the process in real time from first machine to the last machine. Okay, and to the final finished product helps to make the work adjustments for cost effective, for indicating lag in production, eliminate waste and unnecessary work in progress inventory. Inventory management, plant safety and security, quality control. This is again repetition. Now the advantage of the IoT in operation management. IoT provides devices, connectivity. Manufacturing can track consumption and flow patterns at each computer. Managers will have great visibility for each machine on the floor, will know real-time consumptions, actionable insights about the waste, available inefficiencies, impending equipment failures, regulatory compliances, and so we say resource utilizations, benchmarking, predictive maintenance. So resource utilization real-time data allows manufacturers to detect off-hour consumption, optimize manufacturing production schedules, identify anomalies, and capitalize on opportunities for saving. Benchmarking means how these similar parts are to be standardized, and they are, you say, how they are from the different locations they are reaching to this some, you say, common place. Manufacturers can find systems not functioning properly or easy detect of hidden operations inefficiencies and energy waste. Predictive maintenance means you can find out resource intensive preventive maintenance can be eliminated with data backed predictive maintenance. Manufacturers get alert when service will be needed. Unusual consumption patterns can be eliminated, avoiding the high cost of equipment downtime. Efficient production, that is technological and organizational changes to optimize manufacturing process. The same plant can work more efficiently to create the same or greater output. That is our objective, because we have the information of each part of the, you say, industry. So then you can eliminate the inefficiencies. So by eliminating the inefficiency, the same resources you can utilize for a higher productivity or better productivity, you can say. Behavioral changes, it can alert the managers with energy consumption data, can diminish wasteful habits in their team, or install behavior changes in the corporate culture. So the point to be mentioned here is that because the managers will be able to know, to judge how the people working in his organization, his team is behaving, have the psychology to react for any of the work. Okay, so accordingly means whether he is working with his efficiency without taste. Management model, we say, by aligning with corporate social responsibility goals and lean manufacturing, Six Sigma or other management models, energy management programs are trackable and their ROI is very effective, as I indicated earlier also. Operational efficiency and profitability, examining only the predictive maintenance programs made possible by IoT, manufacturers can save significantly over a preventive maintenance schedule. They can eliminate machinery failure, which is costly, as well as associated downtime, which may be even more costly. So just have a look of each machine with a sensor. Now you just have that each machine with a sensor is there to be processed from starting to the end. Okay. How you say the different sensors, and you can say you can manage remotely by using your mobile only, that you can send the signal. Okay. Just I'm leaving this part. A smart factory is referred to as the use of new innovative development in digital technology, including advanced robotics and artificial intelligence, high-tech sensors, cloud computing, the Internet of Things, etc., Within the modular structure, smart factories of Industries 4.0, cyber physical system monitors the physical processes, create a virtual copy of the physical world, and make decentralized decisions. Over the Internet of Things, cyber physical system communicates and cooperates with each other and humans in real time via the Internet of Services. Both internal and cross-organization services are offered and utilized by participants of the value chain. So this is the new setup of the industry, you can say, where at the workstation 1, workstation 2, workstation A to O, that is the movement of the material and the movement of the, you say, the flow of material and the job of the work is done, and final finished product you will get at the end. Okay. So I'll have this video, a 2 minutes video, just have a look on that. my aim to show this video is to have a look of how the movement of the chassis on the track and the automation and the manual part of work, how it will be done or it is going on in the industry. So because a BMW is a premier car consisting of all necessary or required features, which we can say which satisfy all the possibility or the requirement of the customer. We can say the BMW car is also a customized car where whatever features the customer want to add, it is added, definitely increase the cost, but the customized part also will be, or customized feature is also added as per the requirement of the, so we say it is a premier car. How the assembly of the premier car in the industry is there, because when you are saying the combination of the automation and the manual work, because many of the activities are to be checked manually also. Many of the activities are to be checked manually also to check the final, because the final finished product, when it will be in the hand of the customer will not ask that who has done what. Customer wants only a quality product. Final finished product must give a good service without any problem. Problem, it should be free from all problems. Okay, so when it is going through the number of through the number of people or number of processes, then where if in any of the process if there is a lack or there is a deficiency in the operation, then it will affect overall on the brand of the product, because if any part of the car is not working properly or will not work properly, then the customer will only say that this brand is not good, this car is not good. Even certified at the distributor level, but even then the customer will not be satisfied with that. Okay, so because of that things I have shown you a complete assembly of the premier car BMW, starting from the assembly of the components to the final finished product, and then again when you consider the supply of the final finished product from the factory location to the customer point where the customer finally bought it by it, then transportation is also will be by big vehicle, big trucks. So probably if you have not seen the transportation of the vehicle, because they will be transported 2-3 vehicle in one big truck. So the loading and unloading a part of that also will be taken care, because if slight or some scratches or if you scratches on the body of the car also will affect, that is will be a point in the mind of the customer that this is not a good car, he will not buy it. So if some scratches will also be there on the body of the car, then also it will be a negative impact on the mind of the customer. So that affects on the product image or brand image. So the customer will not be ready to buy it. Okay, so means the handling of the final finished product from the factory location to the distributor point is also very important. So each thing is to be looked, and so the data, when we say it will be with the IoT device, with the IoT tracker, so then how it is moving, and so what precaution is to be taken, that will be taken care, or we say the guidance can be given to the people who is handling. And then also we can find that if some problem has been raised somewhere or somebody has not done his job properly, then accordingly the punishment can be given. Okay, so this is now we can say the how we have converted the various skill or the requirement from, like, because it was started in 2015, now we are saying in 2020 what we have, we say up to now. So 10 skills which are relevant to the industry 4.0 up to 2.2020, or you say IoT enabled industry, we say now we have a complex problem solving. The complex problem can be solved easily because we have a advanced computer and we have the information of all the, you say, ground information we have. We say critical thinking. Critically we can analyze all parts. Just if you have seen the assembly, how he is moving his hand over the body of the vehicle, that is checking any deviation, anything, or you say surface, he was trying to find out. Say, so making this smooth. Creativity, you say, the creativity can be, you say, you can, whatever data, whatever you think, whatever you think in your mind, immediately it can be transferred into the actionable form. It can give some shape. You say, you can convert it into a shape. People management means when you have the information related to the human behavior. Human behavior means the people working in some place, whether he is willingly working or not, the work is not according to his will. Then you say how he is reacting. So that is the people management. Which work must be done by whom? That is also you can manage in a better way. Coordination with others, coordinating with others means in this system you have to coordinate with number of people, because in procuring of the materials you have to coordinate with the vendors. That is, the required material must reach to the factory location, and when you are selling your product to the distributor, to the customer, it will be through the, again, duty to the distributors, distributing point, and then retailers also. So you can coordinate all the people and the people in the, and also you can coordinate with the expert also. That is, the people sitting at the remote places, you can coordinate them, you can contact them, you can take the expert advice from the people. Emotional intelligence means emotional, if you say certain emotions can also be converted into the real thing. You can say judgment and decision making. Judgment, you can judge the actions, you can, because it will help you in taking the decision, making the decisions. Service orientation means related to the service, how you take the different concepts, ideas, that is, or the people involved, or you say how we'll think about the services we are providing, because they're for the, and negotiation, when we say the negotiation on the part of the, when we are negotiating with the, you say vendors, we are negotiating with the banks, we are negotiating with the distributors, related to, when we are negotiating with the vendors, related to the supply of raw material. Mainly we are going to negotiate with the payment conditions, because we buy the raw material from the vendors on credit basis, and we give the finished product to the distributor on credit basis. Okay, so the difference of these two, where we have to manage the finance. Okay, so the cognitive flexibility means by which you can make the changes in your product. Okay, so these are the things which we say will be useful. The IoT enabled industry will help you to transfer the information, to take the quick decisions, and to make to improve the productivity and the profitability. Okay, so now it's open for questions.
Excuse me, sir.
Open for questions. Yes.
Yes, now you can ask your question, please. I am audible?
Yes, you in the video you were talking about the this one customization of the car. So if customer customizes it, it will be, I can customize it on from my home, and that will be straight away sent to the factory.
Yeah, yes, when you say, for example, in automobile, you can say you want to add some feature. Okay.
Yes, sir. Yeah.
If you say you want to add some feature, there are two things. For example, in the laptop, if you say, I'll give two examples. First, say laptop.
Yes, sir.
You know, where
Yeah.
you say you want to get a laptop of higher configuration. So there are two things. Either the company already has, you say, with that feature, or if that feature is not available in the present product, then to add it into the product. Okay. So for example, if we in automobile, if we are given that you want to add certain particular features in the product, so maybe higher version, that feature is already available, but you want a lower version and that feature. Okay. So the company definitely will add that particular device into the product, okay, in your car, and will increase the cost. Okay, that is the meaning of the customize. Or maybe size of the another customization may be like the size of the seat, location of the seat, like that you can modify. So accordingly, they will have in advance. If they have that seats, then definitely it can be replaced easily. But if they don't have, then it will take some time, and definitely will be added in the product. Okay.
Yes, sir. Actually, sir, I meant to say that if we customize it from my home, like if I logging in the BMW account from where I am buying the car, so I will give my specification. So that will be uploaded on the cloud, and the same specification can be extracted by the factory directly. Since it is connected through IoT, right?
When it will be because now we say the internet, or when you say when you will say, or like in automobile you want to add some feature. Okay.
Yes,
so
sir.
you will first select some basic car you will select. Okay.
Yes, sir.
And then you will say that you want some additional features in the product you have selected. Okay.
Okay, sir. Yes,
so
sir.
there are two things now. Either those features are already available in under higher model of the car.
Yeah, by default, some are there. Yes, sir.
Okay. Or if they are not available, then the company will say, okay, they can add these features, but it will cost this much. Will be the cost of adding these features.
Yeah.
Okay.
Thank you. Yes, sir. Got it.
Okay.
Thank you, sir.
Any more point?
One more query is there, sir. Tayyab Aman is asking, what are the important functions of operation management? Operation management in the context of Industry 4.0.
Not able to hear.
Hello.
Slide. Volume.
Hello. Sir, I am audible.
Yes.
Sir, what are the important functions of operation management in the context of Industry 4.0?
What are the important functions
of operation management?
Important functions of the operation management
in the context of Industry 4.0. In the context of Industry 4.0.
So I have given the various functions. That is, when you say the Industry 4.0, that is, we are not saying you are not saying a new function. We are saying already what are the different functions which are available, or by which a product will be produced. So all functions we say they are IoT based. Means they will be, a device will be, for example, the machines. Now the machines will be with the IoT device, so that it will collect the data and transfer the data. Okay.
Okay, sir. Sir, one more query from STC Kumar. He's saying that, sir, is there any possibility to make product maintenance work be IIoT enabled?
Your point is that whether that is monitoring. We are saying the monitoring of the machine. When the machine will be IoT devices with IoT devices, then definitely the condition of the machines will be there will be an alert related to the condition of the machine. Because when you say a machine is provided by the manufacturer, so the manufacturer will give that which component or which part is to be replaced when. Okay, that will be part of preventive maintenance. But when we say a predictive maintenance will come into picture based upon the usage of the machine. So
Okay, sir.
when you say it will be IoT devices attached machine, then you say condition of the machine, you say condition will be a one parameter in the IoT devices, that the condition of the machines will be tracked by the IoT devices and will give the alert that this is the maybe you say some temperature rise of some part is there.
Okay, sir.
The example, some temperature rise or some vibration in some part of the machine may be there. So this will give an alert that there is a vibration in some part. Okay, like that. So
Okay,
means the person sitting at the control room will have the observation that there's some problem in that machine. So either he will stop the machine, or the person working there, they will say that check that machine. There will be an alert on the screen.
Okay, okay,
Means
okay.
that is the predictive maintenance. Okay.
Any query? Anyone want to ask some question?
Excuse me, sir.
Yeah.
Yes.
So actually, in like you are now told about maintenance. Suppose if there is some troubleshooting or some error happening in the machine, so how does IoT will play a role here? Means if that something goes wrong.
As I have mentioned,
Yes, sir.
IoT only will give the information related to the condition of the machine.
Okay, okay, sir. Okay.
There will not be an automatic repair or replacement by the IoT devices. IoT only will collect the information and will
Yes, sir.
transfer the information related to the condition of the machine, and then the action means it will help to take the action immediately. There will not be any delay. Means they only by the data correction and data transfer we can reduce or we can eliminate the delays. Okay.
Yeah, got it, sir.
Yes.
Thank you, sir.
Okay, I think that now it is the right time to close. So thank you, sir, for having such an informative session with
Okay.
the participants. And you have covered the role of operation management with the IoT concept so nicely. I think that all the participant will be really benefited with the knowledge which you have provided in this session. So on the behalf of the organizing team, once again I thanks you and thank for having your precious time for
I'm thankful to the organizer and all the audiences.
from your busy schedule. So thank you, sir.
Okay, thank you.
Thank you, sir.
Should I close?
Yes, sir. Yes, sir. Thank you, sir.
Okay, thank you.
Okay, sir. Okay. उनको बोल दो participants को कितने में
Dear participant, we are going to join again at 2:30. Let's have your lunch and meet again. Till then, thanks.
Thank you, sir.
Good afternoon to all. Professor V.K. Gupta is with us. Uh, Firstly, from the organizing team, myself, Dr. Avril Mishra, would like to welcome Professor Vijay Kumar Gupta as a guest speaker and thanking him for accepting our invitation. Thank you, sir. Dear participant, before handing it over to Professor Gupta, I would like to share a brief about him. He is currently the senior professor in the Department of Mechanical Engineering, Triple ITDM Jabalpur. He has done his MTech as well as his PhD from IIT Bombay. With a 20 plus years of experience, he is currently acting as a Dean Academic Post in the Triple ITDM Jabalpur. His area of interest for the research are smart structure, robotics, mechatronics, mechanical vibrations, energy harvesting. Professor Gupta got award in the year 2003 from Indian Society of Advancement for Material and Processing Engineering. Also got the fellowship from the Japan Society for Promotion of Science. He has more than 50 plus publications with a citation of 400 plus. He carried out 9 projects that as PI and co-PI. He has authored around 10 plus books and book chapters in his account. Now, I would like to request Professor Gupta to carry with his session talk. Professor Gupta.
Avril sir, hello.
Yes.
Yeah, Professor Gupta is there. So I think there is some technical problem.
Okay.
I think sound is not is going in that side. That's why.
Okay.
So I am in the communication with that side.
Okay, sure. Participants, there is some technical glitch. As soon as it will be rectified, we will join the session. Please keep yourself in this meet. It will be started soon. sir. Yeah. Now you are audible, sir.
ठीक है मैं
अच्छा।
करता हूँ हाँ।
Yes, sir.
Aviral sir,
Yes.
hello. I think
Now, sir,
we can.
voice is going. Yes.
Okay. Now, sir, we will starting his presentation.
Okay, good afternoon everyone. So are you able to see my screen?
No, sir. Yeah.
Yes, sir. Yes, sir. Yes, sir.
Okay. Yes, sir. Yes, it is there. Okay.
Okay. So today's topic is the robotics and automation for Industry 4.0, and after the lunch it is difficult to stay awake, but I will try to make you remain awake basically. So what I will do is basically before starting the actual topic on robotics and automation, I will show you two videos basically. So these videos are of the robots which has been developed at MIT. Are you? I think you will be able to see this video.
Yes, sir. But it is not running, sir. Yes. Okay, sir. Fine.
This video shows basically the technology which is being developed and how it has been perceived and how you can use it for different purpose. The cheetah basically it will not be directly involved in the automation part for robot industry 4.0, but it will help basically to understand the way. So it is able to adapt to the different obstacle size. So in real world, when we are implementing the automation, also we will encounter such type of things. So this is the real experiment basically. And basically it is mainly a combination of the mechanism, the control system, and the inbuilt AI and other things basically. Image processing, AI things basically. So it is a combination of all the domains of engineering basically. So I will go to another video. This is the Atlas, nearly humanoid basically, and the basic thing is here is the balancing is important in this case. So it is jumping over the obstacles from one obstacle to another, different heights of the obstacles, turning it, and then you can see that how it is doing the balancing. That is important part here. So that means, and then it can overturn also, totally overturn also. So if you see here when it is touching the ground, how it is balancing. So dynamics is an important part here basically. It was developed in 2017 by Boston. So it is just like when we jump and we take turn, how we will balance our body. Same thing is mimicted in this robot basically Atlas. And third robot I wanted to show is the handle. If you see this robot, it is a combination of the mobile wheel robot and the mobile leg robot. So it can cover both type of terrain basically, where it can run fast because it is having the wheels. This front legs, they can help it balancing also, and then they will be helping it to overcome the obstacles sometimes. This can also act as just like a hand also, so it can pick some objects and other things. And if you see the posture of the legs, these legs are the basically the controlling, the balancing the total load. So in this example, they are showing that the 2 points, endpoints are basically remain at the fixed point, and then they are. This is the example how they are. It can be used for carrying the load from or transferring the load from one place to another, moving over the stairs, and moving in the different types of terrains. It can easily move in the different type of terrains basically, and even jump over the obstacles. So all of it contains the image processing, the sensor systems, the control, and the dynamic actuations. So with this aim, basically in India also we are trying to develop such type of robots, and with this aim, I am starting today's session basically. I had used number of images in this presentation, and they've been taken from different sources. Some of them I had referred, but many of them I could not refer properly because various times I had collected these images. So I am thankful to all the authors for their publishing their work, which helped in building this presentation. Right. So coming to the industry, this workshop is towards the industry 4.0 or smart manufacturing basically. So you are now very well aware what is the industry 4.0, and we are talking about the era in the fourth generation of the industry, where we are talking about the cyber physical systems. So according to McKinsey and Company, industry 4.0 is more than just a flashy catchphrase. It is a confluence of trends and technology promises to reshape the way things are being. So the developments basically, if we see the third industry revolutions, also the automation has come, and now in fourth revolution also we are talking about the robotics and automations. So how we can club the two things basically, industry 4.0 and robotics, that is the basic aim. So what I planned today is the basically initially some introduction to robotics. I don't know the level of the participants. If you are very well familiar with the robotics area, then I will be sorry for you because I am starting from the fundamentals only, and then later on I will be giving you some information regarding how we can club it with the industry 4.0. One case study of BMW also I will be presenting in presentation. Right. So as you are aware that these are the 9 pillars of the industry 4.0, which includes the advanced manufacturing solutions, additive manufacturing, augmented reality, simulation, horizontal and vertical integration, industry internet, cloud, cyber security, and big data and analytics. So these 9 technology has helped to for the starting of the smart manufacturing, or we can say the era of the industry 4.0 industrial internet of things. It is the same definition being used at different countries basically. So in this 9 technology, if we see the first of the technology is the advanced manufacturing solutions. Advanced manufacturing solutions means we are talking about the autonomous cooperative industrial robots, integration of the sensors, and standardized interfaces so that the whole system, whole manufacturing system becomes autonomous. Autonomous basically we means that it is independent of human intervention. It can take the decision by its own. So with this aim, in the International Federation of Robotics has stated that by 2018, global sales of industrial robots will be average grow year on year by 15%. So they predicted that there will be a 15% growth year by year in the field of robotics. The reason that is stated is the flexible production is a main point of the Industrial 4.0, which includes constant operation at high speed, reduced operation cost, the system should be reliable, and robots are giving the flexibility for arranging the things in Industry 4.0. And in Industry 4.0, what we are aiming? We are aiming to a single load production. And these flexible production systems with the help of automation or with the help of robots, the single load production can be made. Similarly, simulation and automatic program creations helps automate the system. If we talk about how the robotics has helped or the Industry 4.0 and robotics are related, this is basically the GM's statement. Basically, GM what they have done. We are very well aware about the Fanuc controller. Cisco is already there. So GM has developed a ZDT, zero downtime solutions. So it is basically a cloud-based software platform to analyze data collected from robots across GM's vehicle. So what they have done, they have collected the information by using the robots across their factories, and they try to develop a system which results in a zero downtime. That gives them zero downtime. So they launched it in 2014, and it was initially built to eliminate the downtime time. And now they are moving towards the things. They are aiming that the whole system can become the flexible systems. So with this system, they were able to avoid over 100 significant unscheduled downtimes, and particularly in the automotive industry, per minute downtime cost around $20,000. So you can see how much savings they are able to do by adopting the solutions. Another feature of ZTT that GM and partners are working towards is the real-time process improvement. So they are trying to improve the process parameters, how the process can be improved. That is their aim now, right? So Industry 4.0 has provided unforeseen benefit for manufacturers, despite the fact that companies like GM are pushing the boundaries of what is possible in automation and implementing the future of Industry 4.0. Right? So with these statements or with these words, I first introduce you with the robotics. I am starting with the very scratch, basically very fundamental of the robotics. So what is a robot? Robot term we are listening in daily life nowadays. So robot basically is a electromechanical device with multiple degree of freedom that is programmable to accomplish a variety of tasks. And according to Robotic Association of America, they defined this term for the industrial robot basically. Remember this. But nowadays the robotics has grown. So it has become a locomotion area. It has become mobile robots. It is entered in the aerial robotics also. It is entered in the water-based robotics basically, right? So according to Robotics Association of America, an industrial robot is a reprogrammable. These terms are which are having the colors. These are important basically in the definition. So we want this to be reprogrammable. Means it is not that we are having only one program and we are running only that program. Otherwise, we can call our washing machine also as a robot, because in washing machine generally we have the fixed cycles, and these cycles we cannot change, we cannot reprogram it. It is the manufacturer who is programmed, and we can just work on this. So that is why it is a machine, it is not a robot. So in a robot we expect that we can reprogram it. It is a multifunctional. So it is not a single function machine basically. Although robot is a machine, but it is a reprogrammable machine, it is a multifunctional machine. So it can do variety of tasks. It can be used for the welding also, it can be used for the painting also, right? While in the automation, what we do is that we plan it only for a particular task. So if I compare robot with the CNC or NC machines, NC and CNC machines, what we do is they perform a certain task. Their task is only to perform the machining. And this machining, we can program it, and accordingly it will be changing the job piece creation basically. So what type of job is to be created, that will be defined from this. So while in robot, we expect that it will be able to perform the multiple type of tasks. So multifunctional. Manipulator, because it is industrial robot, so it is called as manipulator. It is designed to, initially it was designed to move the materials, parts, tools or specialized devices. But later on, this movement has been changed to different tasks also. So it can perform certain tasks, means we can do the welding, we can do the basically the painting, we can do the assembly, even we can perform the task of the CNC machines also. So variety of tasks can be performed, and this variety of tasks can be achieved through the variable program motions. So nowadays, if you learn this, you know the term basically that path planning of the robot, trajectory planning of the robot. That is a domain where artificial intelligence, ANN, neural network, reinforcement learning, they are making a changes. So these variable program missions can be achieved in a robot. So I had already discussed that what is a robot. By general agreement, a robot is a programmable machine that imitates the actions or appearance of intelligent creature. The robot, initially the manipulators, they have been imitated the human arm. So if you see the initial robots which has been developed like Puma, Univate or other robots, they were just replica of our human arm. So first joint is our shoulder joint. Second joint comes the elbow joint. Then comes our palm, so our hand, and then we can have the gripper. So that is how the robot's initial manipulators have been developed, right? Nowadays, robots, humanoid, you have already heard the name of Asimov and other robots. So humanoid has been created. Various other intelligent creators have also been copied, particularly in locomotions, where we want the robot to be used for movement from one place to another. Instead of mobile, simple wheel robot, leg robot is more beneficial, where you have the large number of obstacles, the big size of the obstacles. So in such cases, the leg robots becomes popular. So one such robot is the hexapod robot, which has been copied from the spider. So the movement of spider has been used in this, right? So similarly, various other robots have been developed. So to qualify as a robot, a machine must be able to sensing and perception. So these four are the important part of the robot. Otherwise, it will be simply a machine. So sensing and perception means we are collecting the information from its surrounding and taking the action according to that. So suppose, for example, we say that we have all the sense. So if we touch something hot, our hand will just move away from the hot place. We just take it back because our sensor, the human skin is a sensor which is basically being used in the robots as the tactile sensing, touch sensors. So you can just touch and then see how, whether it is hot, whether it is cold and other things. Similarly, some obstacle is coming when we are driving a car. So we can see that someone is coming in front of us, we can turn the car. So eyes are there, so that is image processing, images. So camera is being used similarly in the robots and other things, right? So what we are doing with the sensor and perception, basically we are gathering the information from surrounding. This information will be then analyzed. We cannot just say that if I am touching something, I have to take it back. I have to decide whether I am touching the hot place or whether I am touching something which can damage my skin. Then only I will be removing, otherwise there is no problem. So we have to perceive what is happening around me, and then accordingly we have to take the actions. Sensing and perception is one of the important requirement for the robot. I had already told you that carry out the different tasks. We can do the locomotion, means moving from one place to another, or manipulation. Manipulation means just like our human hand, we can pick something, we can transfer with the help of our hand one place to another, we can turn it, we can rotate it, and all this. So that is basically the manipulation. How we manipulate the object with our arm. So same thing is being copied there. And do something physical. There should be some motion to be involved, basically. Any type of motion can be involved, so that is what is required, right? Third requirement is reprogrammable. That means it can do the different things. And then fourth requirement is it should be able to function autonomously and or in interaction with the human beings. So autonomy is one of the basic requirements for today in robots. And Industry 4.0 is aiming towards this autonomy. And that is why the robots becomes an integral part of the industry, or it is the technology which is integral part of the. Right? So this is the same thing I discussed, that basically what is the difference between a robot and machine. You might have seen the bottling machine, it is the automation. You can place the bottles, one by one they are filled, the caping is done, and then they can be removed, they can be packed. So this total thing is only one type of task we are doing, so that becomes the automation. And robots becomes the advanced, that we can, instead of one type of movement of the bottles, we can do different type of movement of the bottles, or we can pick and place it from one place to another, then it becomes a robot, right? Dishwasher is another example of the machinery. Paint sprayers, only sprayer basically. But if I can paint different surfaces using the robot, then it becomes a robot basically, right? Robots are designed to carry out a variety of tasks. Pick and place arms, mobile robots, CNC machines basically it is not directly a robot. It becomes a basically autonomous cutting operations, basically the cutting or whatever operation we are performing. So these are the machines, not the robot. But line between robot and these machines has become very blurred, because variety of tasks can also be achieved in the computer numerical control systems, basically FMS we are talk about. So there we perform the machining also, we transfer material handling is also involved in all this. So that is why the line is blurred nowadays, right? So yesterday means when robotics had just evolved, this was the robotics. Just the robot was fixed to a particular place, and the robot arm, or we can say the gripper, is moving from one place to another only. So this type of motion, a fixed motion was involved in this. But today, robot can do variety of tasks. This is the example of the painting robot in the motor company. Unfortunately, I did not put the source for this. Problem with the human beings is that over the time we lack the accuracy. We become tired and accuracy losses. So that is why the robots have been replaced for this purpose. Right? This is the robotics today. This is the skeleton has been shown basically for the humanoid robot. We have a robot which is mounted on a mobile robot. So we have mobile robot, we have an arm, we have the control panel here, we have some image processing and other things, and we can do the various tasks. So this type of chairs can be helpful to the physically handicapped persons. Right? Similarly, robots have been developed to play the various games. So here they are playing the soccer, even dancing and other things. Right? So let us come to the robots classification, basically how we can see the robots. So first part is the manipulator. Oh, sorry, it is not showing the images. I can show you. This is the manipulator basically. Or what I can do, this is another manipulator. So these are basically being used in the industrial environment for the automation purpose basically. Then we have the leg robot. This is an example of the leg robot. So these are the legs and it can move. Wheel robot, the Mars mission, the wheel robot which played a significant role. So Chandrayaan 2 also carried the wheel robot, but unfortunately it collapsed. So these wheels robots, they require to work in the different environment. They have to be designed. The interaction between the soil and the wheel is important part when we are designing the wheel robot. Then underwater vehicles like this, or we have the aerial vehicles. So drones have taken basically the lot of things are being transported, particularly material handling things. Drone has played nowadays an important role. They can carry the small load, but they can be quickly transfer the load. That is the main advantage. So aerial vehicles here. And then the robotics is copying the human hand. So grippers, the fingers, and the exoskeleton. So medical field, basically these fingers plays an important role because we require the precision. At the same time, it should be able to apply the certain force So that particular force can be sensed with the help of sensors, such that here also there is a touch sensor which is there. So it can measure what is the force being applied. If slippage is there, we can mount a tactile sensor, so we can see or we can detect whether the slippage of the object is there or not. Right? The robot, we know very well aware, we are very well aware that they are designed for replacing the human for the dangerous jobs. Initially, this was the basic aim. Then to replace the repetitive jobs, because a repetitive job will become bored, stress is increased. So labor intensive humans are being replaced by the robots. And then performing the task which human don't want to do. Just cleaning this and other things, right? So these were the initial aim, and then later on it has been changed. And now today we are talking about the smart manufacturing. So everything is automated. So different types of robots have been developed. I had already discussed the manipulators. So manipulators includes these arms, and then they also include the hand portion. Right? If I mount this manipulator over some mobile device, then it becomes a mobile robot manipulator. This is another example of the mobile manipulator. Then we can have the locomotion. So you can have the aerial locomotion. You can have the wheel mobile robots, leg robots. This is another example of the leg robots, humanoid and underwater robots. Then exoskeleton. So wearable robotic arm and teleoperated robotics. Particularly this can be used for the surgery purpose. It is being developed by KIST. Right? Then humanoid. Lot of interest has been developed over the years, and in India also nowadays the focus is towards the development of humanoid. So now, if I'm not showing the video, but if you go to this site, now site, you will get the video and you will see the capability this robot has. So it is having the various sensors, touch sensor, the cameras for vision sensor basically. Then when accelerometers, gyroscope, so that when it is falling, it can detect that it is falling, and then it can take the corrective action. Ultrasonic sensors to detect if it is hitting somebody, some obstacle is coming, and all that, right? And lot of artificial intelligence has been built in this way. Asimo is the similar robot which has been developed by Honda. It is in the category. Fujitsu also has developed the biped robot. If you carefully see all these biped robots, basically the structure, if you see here, these legs, they are bended on the knee. Whenever these robots are moving, they will not be moving in a straight posture, just like the human being. They will be always having the knee portion which is bended. This is to balance the robot basically, so that the robot should not fall when it is moving. Right? These are some more examples. Basically, the Asimo is playing a football. It is moving on the instructions. This is the Pateman robot which has been developed in the lab, and then it has been trained. This is the RoboNote NASA has developed. So basically, just like the astronaut, it is doing. This is the Sony. So this is the dancing robot basically. So they can dance in synchronous with each other and all that. And this is the Atlas, the example I had already shown. So it can jump also. Most of these robots are only moving, while Atlas being developed by Boston Dynamics basically. So Boston is famous lab. Basically, they are very advanced in the dynamic motion. So they develop this and it can jump and then balance it. Some more animal-like robots. For example, I was talking about the spider. So these are the robot hexapod. This is another spider-like. This is another 6-leg robot. This is a 4-leg robot. And I'd already discussed this Sony robot, which is the copy of the dog, basically. Huh? We have Sony Aibo with toy robot, and these are some details of this. Basically, if you see that it is having the motor, it is having some electronic circuits mounted in these legs. It is having the vision system. Right? I had already shown this movement of the cheetah. So why we are copying the animal's motion? Basically, the cheetah is aimed basically that we want to move at a faster speed, thus they at a speed cheetah can move. So in this, the motion of the body, it has been copied from the how the cheetah moves, how it is taking the jump. So all these aspects have been taken and then it has been developed. Right? And then this handle, it is not Atlas, it is the handle basically. This I had already shown you. Okay. Then in the Mars exploration, this robot has been developed, Sojourner rover, and it has helped very much in the Mars exploration. Some more autonomous robot example. This RX is basically it is a 6-leg robot, but legs are not just like the leg. It is basically the half circular section you have. So it is just a half circle arm rim. It is not the full thing. It is the rim which has been there. Right? This is a robot, basically the SWMR, which has been developed at IIIT-DM, and it can move in the different terrains, whether it is the sandy area, whether it is the boulders area. And the major advantage with this is that it was controlled basically wirelessly, but the movement is stable. So it can carry different loads and then you can move it. It is able to move over the stairs also. Pegboat is another robot which has been used for the shoulders. So these are the autonomous robots. Nowadays in the industry, this swarm robotics has also become important thing. So maybe if I can run this file. Because in smart manufacturing, this collaborative or robotics, it becomes an important part. So in this, basically what has been done is that number of multiple robots has been used. So they can, suppose it is to move over this, then it topples down. But if 2 or 3 robots, so once it reaches in that arena, so how to find this robot? They use the flying robot. So that flying robot, aerial robot is now looking. So it is identifying the robot which are nearer to this. These robots will be aligned. So it is basically the color matching. So they are moving it now in synchronous way, right? So now when these four robots are clubbed together, they can easily move over the obstacle. So the task which single robot could not do, it can do. So you can move the heavy load. So in industry, basically, this collaborative or swarm robotics, so cooperative robotics, it becomes important. So these were the various types of robots which have been developed. And now coming to some basics about the robot, particularly in smart manufacturing, we will be more concentrated towards the manipulator. So my focus is towards the manipulators. So robot configuration basically. The robot can be classified based on the physical configuration and control system. Here robot means the robot. So classification based on physical configuration, you can classify them as the Cartesian, cylindrical, polar, spherical, jointed arm or articulated robots. So this is the various robot coordinate classification basically. So you can have all three axes as the prismatic joint, means linear movement. Then it becomes the 3P type of configuration, which is known as the Cartesian configuration, right? Here it is not cylindrical, it is basically the prismatic joints. Sorry for the error here. So this is the Cartesian coordinate system. So you can move along X direction, Y direction and Z direction. With Y according to your convenience. The second configuration is the cylindrical. So cylindrical means you are having this movement along the radius direction, movement along the vertical direction, and third direction is the rotation. So you require two prismatic joints and one revolute joint. R2P. Two prismatic, one revolute. Third configuration is basically the spherical joint, spherical robot. So spherical means you require the two rotations, rotation about x-axis, rotation about this, and the third is the linear movement of the arm. So you have one prismatic joint and two revolute joints. So 2RP. Fourth configuration, which is basically the copy of our human arm. That is why it is known as the articulated robot or anthropomorphic robot. So it has all the axes as the rotary axis, and these all axes are parallel to each other. Basically, it is the arm portion only, the hand portion is not considered in this. So that is why we are having 3 rotations. One is corresponding to the shoulder joint. So this one is the shoulder joint. Second is the elbow joint. And the third joint is our basically waist motion. So it begins with the waist movement, the shoulder movement, and the elbow movement. So we can move in the 3D space anywhere. So this is the 3R robot, articulated robot. And last one is the specially designed robot for the assembly purpose. So it is known as the SCARA robot, Selective Compliance Assembly Robotic. So it has been selected basically to just for the assembly. So pick and place type of. So I pick some item from one place, I place it at another place. So that is the basic aim. So with this aim, basically what you have is this one joint, this is another joint, and these 2 joints are parallel to each other. And third joint is the linear joint. So 2 parallel revolute joint and 1 additional prismatic joint. That makes the SCARA configuration. Right? So this is the classification based on the configuration, physical configuration. Then you can classify it based on the control based. So initially the classification was point-to-point configuration, point-to-point control, continuous path control, or control path robot. Nowadays it has become autonomous control systems also. So it can take the decision by its own now. Right? If we talk about the robots and its subsystems, so we have the basic part of the robot is the mechanical part, which is the mechanism. Mechanical. Then we have the electrical part, motors and other things. The electronic part, electrical and electronic combined basically. So we have the control system or electronics involved, the motor controller, the other sensors and other things. Then control part means we program these robots. So controller, maybe it can be the arm controller, it can be some other controllers. And then a power source. These are the 4 major ingredients of a robot. So this is the one system. So where we have the goal, we give the command to the actuator that move. Suppose I want to move from one place to another, I give that move the shoulder by this much angle. So accordingly the shoulder will be moving. But now the problem comes is that when it is in the physical system, there may be error. So we have to build a sensor which will detect that how much angle the shoulder is moved. If it is not moved by the proper angle, we have to correct it. So the controller becomes an important part here. So this is a control loop, which is the general control loop which has been shown here. Right? This is the anatomy basically. So if I compare it with the human being, the mechanical linkages is our body. So we have arms. So that is the mechanical link. Then we move different links. So for movement, we require the actuators. So we have the actuators and the transmission systems means the gears and other devices to control the motion is and other things. Right? Then sensors. So we can have different type of sensors which can detect. And finally controller, which will be controlling this. And all these requires the power, so power supply units. And we require the user interface, right? When we talk about the mechanical point of view, so this is one example of the robotic arm. So we have the base. These are the various links. Various links joined together with the joint, with the help of joints becomes a kinematic link. These links are basically joined together, so it becomes a chain. But remember, it is not a closed link chain, it is an open chain. So last link is not connected to the first link, so it becomes a open kinematic chain. Right? We require different actuators, so these are various actuators. We have various types of motors. We use stepper motors, we use servo motors. For heavy duty, we may go to the AC motors. For very small applications, not precision applications, we can go for the DC, simple DC motors also, and all these, right? Where the load is heavy, then we go for the actuators. These can be pneumatic actuators or hydraulic actuators. So here are the different type of actuators shown. Single cylinder, double cylinder, telescopic cylinder, and other things, right? All these. And we have the transmission system, a gearbox like this. This I had already discussed, basically hydraulic and other things. Right? Third part is the sensors. So sensors provide feedback to the control system and give the robots more flexibility. Sensors such as visual sensors are useful in the building of more accurate and intelligent robots. The sensors can be classified as follows. You can have position sensors, you can have range sensors to determine the distance from a distance or from a receiver or obstacle, right? Velocity sensors to know the velocity by which we are moving. Proximity sensors to know whether we are in the near vicinity of some of the obstacles. So we can have infrared, acoustic, touch sensor, force sensors, tactile sensors, all of these. Right? This slide shows the number of sensors basically. It covers the number of sensors which are magnetic sensors, the compass, the IR amplifier sensors, IR sensor with lens, and other things, right? Number of sensors. Then third part comes the fourth component is the controller. So this is the basic controller which is being mounted in almost every robot. It has the processor. It can be interfaced with the various sensors, and you can interface it with the actuators. So based on the, and we can interface with it with the some devices like these controllers. Right? So it is also having a controller inside it. Right? So these are all controller parts. In robotics applications, various controllers have been used. For hobby, we use the Arduino Uno or Raspberry Pi. Right? So limited sequence control, playback with point-to-point control, playback with continuous path control, or intelligent robot. Next part is the end effector, because we have to perform a variety of tasks. So we have to grasp something. So we can have a gripper to grasp and manipulate the object during the work cycle, or we can have the tools. For example, we are performing a welding, that means I am having a welding rod mounted inside the gripper. Similarly, spray painting, we can have the spray system which is mounted, spray gun, and then we can move it. So this is the end. These are the variety of the end effectors which has been developed over the time. Right? So this is about the robot classification and important part of the robot, right? Now there are certain more terminology which are associated with the robotics, particularly the degree of freedom of a robot. In mobile robots, we call it as the mobility. So it gives us the number of independent motions of a device it can make. For example, in this case, we are having the 5 degree of freedom. How? I can rotate it about this base. So this theta 0 is the first. Then theta 1, I can rotate it about this base. That is the second joint. Third joint is this joint between this link and this link. So this link can move independently with respect to this. So this is the third joint. Then another joint in between the link B and C. So this is the fourth joint. And fifth joint is the final end effector here, which can rotate about its own axis. So it is having only the gripper, and then it is. Generally, what we do is we add along with this half degree of freedom, which is generally used for the gripper, because gripper is having only two positions, either it is in the open position or it is in the closed positions. We cannot have an intermediate position. So generally, the grippers are generally given half degree of freedom. They are represented with half degree of freedom in robotics. So I am having a gripper here also, then this becomes the 5.5 degree of freedom. For a robot to work in the 3D environment in space anywhere, we require minimum 6 degree of freedom. These 6 degrees of freedom are the movement along X direction, movement along Y direction, movement along Z directions, rotation about X axis, rotation about Y axis, and rotation about Z axis. So 6 degrees of freedom are the minimum requirement. Right? Manipulator I had already discussed. Then workspace. Whatever work we are performing, it should be able to, the robot should be able to reach to that place and in a particular orientation, required position and orientation. So the volume in space that a robot and a vector can reach both in position and orientation is known as the workspace. Now in case of robotics, particularly manipulator robotics, what we define is the two type of workspace. One is known as the reachable workspace. Reachable workspace means I can reach to the particular point, but it is oriented, I cannot orient it in my desired directions. It can orient it in one or two directions, right? But if I can reach to the particular point, and if I can orient it in all the directions, possible directions, means whatever direction is required, I can rotate orient the robot in that particular direction, then it is known as the dexterous workspace. So here in figure, a cylindrical robot half workspace is given. So if you see here, this is the space where robot can easily So we have the position, we have the orientation, link and joints I had already discussed. Now in robotics, when we do the robotics, we study the robotics, kinematics is an important part. We have two types of kinematics in the manipulator, basically. Forward kinematics. Forward kinematics means given the joint angles, at what location I am reaching. So as I move my shoulder by say 30 degree, I move the elbow by 45 degree, what will be my final position of the wrist? So that is my forward kinematics. But if I require that I know the final position of my wrist and then determine the movement of the elbow, movement of the shoulder. In that case, it is known as the inverse kinematics. The problem with the inverse kinematics is that not all the things are solvable, and all the things cannot be solved basically, so we don't have or in some cases we will not be having any solution, right? That is it. Then the kinematics. Oh, one more thing in the inverse kinematics, you have the multiple solutions. You can reach to a particular position in multiple directions. So that means you have the multiple solutions of the problem. So given the position, what will be my movement of the shoulder, what will be the movement of the elbow. For each of these, I will be getting two number of solutions. So I may get for a 2 degree of freedom, I may get 4 possible solutions, and I have to determine which one I have to use. So that is the biggest challenge in the inverse kinematics. In kinematics, we don't consider the forces, but in dynamics, we consider the motion along with the forces. So when we try to design a robot, we have to determine that what will be the size of the motor to be required. So in that case, we have to perform the inverse dynamic analysis. Maybe Newton-Raphson method or other methods basically we can use, and then we can determine what will be the force required, what will be the torque required by the motors, and accordingly we have to purchase them. So dynamics is important. Actuator and sensors we had already discussed, I am not discussing. Right? Another important parameter when we design a robot is the speed which we require. Sometimes it becomes difficult for controller to calculate the next position within a particular time because the processor takes time, and in between if you try to perform the task, then the controller or the actuator will be getting half information based on the previous information or previous location, and the half information based on the new location. So a synchronous effort is needed between the robot system, the robot actuation, and the controller basically, right? So in that case, the speed is important. Load bearing capacity of a robot is the maximum load which can carry, right? If we require precise movement or precision is important, then you will always try to go for the lightweight robot. Right? Other two terms which are related to robotics is the accuracy and repeatability. Accuracy means if I can reach to a particular position without making a mistake, that is my accuracy. Right? But in most of the cases, it is impossible to get a machine exactly. 100% accuracy is not possible. So basically, accuracy is defined as the ability of the robot to position itself to the desired location with the minimal error. Normally, this minimal error is the 25 micrometers precision. Right? Repeatability. If I am performing the task, if the task can be performed repeatably, then it is the repeatability. Right? So, accuracy is an absolute concept and repeatability is a relative concept. A robot that is repeatable may not be very accurate, or a robot which is accurate may not be repeatable. So this figure shows the accuracy and repeatability. If you see all these figures, in this figure, all the target points hits are varying. They are not at a particular location. Right? So that means this robot is not accurate. It is not able to perform the repeatable task. Instead of, if I consider this configuration, here robot is reaching towards the required goal, but repeatability is not very good. So from here to here, the repeatability is increasing, decreasing, accuracy is increasing. But if I go to this location, that means I'm reaching the accuracy, at the same time repeatability is also good. Right? In this case, I am having good repeatability, but accuracy is not. If we discuss, now we have seen the robotics area basically, so now we will consider it with respect to the manufacturing. So according to Mitsubishi Factory, new kinds of application and tasks can be handled by collaborative robots. Right? So Mitsubishi Factory, they are talking about the collaboration between the robots. Right? While the traditional industrial robots were cooperative type of robots. So if we see the comparison of this, traditional industrial robots are used to improve the performance of the machine very fast and precise. They can interact and cooperate with the human beings with redundant speed, torque and limited position. While the collaborative robot supports the work like human safety first. So when we are talking about collaborative robot, so they take care of the human safety. If they are touching any or they are about to collide with some human being, in that case, they can take the preventive action, right? And collaborative robots are slow and easy to use and easy to move. Human can work all the time close to the robot. So we can say the collaborative robots are more complementary to the industrial robots than a competitor to the traditional industrial robots. And Industry 4.0 is requiring this. Right? If we see the cooperating robot for Industrial 4.0, this is the example. So it is able to press this switch here. Right? The task which is being done by the human is being replaced by the robot. Right? So force, they have the force sensors to control just like the human beings. Right? They have the camera to see like a human being, 3D vision system so that they can pick the beans, etc. And their first priority is the safety. So worker can interact with the robot without stopping the robot. Right? These are the various applications. You can have machine loading, industrial application, welding, pick and place, sampling, assembling, manufacturing, surveillance, and other operations. Right? Some more applications are here. One robot is performing the task of loading and unloading. This robot is placing the desk stuffs. This is a FANUC control robot. It is doing the painting, FANUC robot. Right? So here it is doing the assembly basically. In BMW, it is the robot has been removed. Basically, the operation has been done. This is an arm based on force feedback control manipulator arm. And this is the medical robots. Right? So if we see the robots, advantage versus disadvantage, robots increases productivity, safety, efficiency, quality, and consistency. Robots can work in hazardous environment without the need. Robots need not environmental comfort. They can work continuously without experience the fatigue. They have repeatable precision at all times. Robots can be much more accurate than the human, but sometimes I contradict with this. The humans which are performing the same task for the years, they become more accurate than the robots. Robot replace human workers may create the economic problem, but nowadays human and robot interaction is increasing, so this problem is overcoming basically. And robots can process multiple tasks simultaneously. That is the advantage. If we go for the disadvantage, in case of emergency, they lack the capability. Our human mind is having very fast actuation, but robot, the sensor will detect some ill function, then it will send the signal to the controller. Controller will first analyze and then will be deciding the corrective action. The corrective action will be sent to the actuator, and then final actuation happens. So this may take the time, while human brain is so fast, so we can respond very fast in case of emergencies. Right? Robots, although superior in certain senses, have limited capability in terms of degree of freedom. The flexibility we are having, robot cannot have that. Dexterity means the reachable space with a particular orientation. Sensors, vision system, and real-time. Another disadvantage with the robots are costly due to initial cost of equipment, installation cost, need for peripheral, need for training, and need for programming. So what robotic developers they do, they analyze that over the years what will be the break-even point, and accordingly they fix the cost of the robots. Right? If we talk robots with respect to Industry 4.0, but before this, if you have any questions, anything, this was the introduction to robotics. Right? So anything related to this you want to ask?
Okay, thank you, sir. Now I request our participants, please ask if you have any query.
Any questions or anything?
Sir, one question is in chat box. Which is costlier among cooperative and collaborative robots?
Okay, then what I do is basically, now I come towards the Industry 4.0. Right? So various robots have been developed for the Industry 4.0 point of view also. This is a comparison which has been presented in a paper. Basically, it was a journal technology, basically Malaysian journal, and from there I had taken so various robots, what are the model, what is the company, and what is the description. So if you see here, Sphere, the revolutionary new high performance collaborative robot designed to execute machine tending, circuit board testing, and other precise tasks that are impractical to automate with conventional robots. Robota, it is a light, adaptable, and inexpensive six-axis industry mode. So here adaptation means adapting the system, means whatever is happening in real time, we have to adapt it and then accordingly work. So that is the major part of this robota. So it was specifically developed for small, medium-sized enterprises which are focused on flexible and efficient automation. Others are CR35IA by FANU for automotive assembly line. BioRob arm, Bionics Robotics is developed, lightweight BioRob robot, certified safe for use in close proximity with human robots. So basically nowadays, when we are interacting with the human beings, the soft robotics is the another direction which is becoming popular. So BioRobot is one more particular this direction, right? P-Robo, SPD10 and other things, right? PR5, PF400 by Precision Automation. So with little automation experience, but it is a powerful and fast enough to support light duty assembly operations. So these are the robots the company has, the paper has compared. I will be adding to this the two robots particularly. One is the KUKA robot. So this KUKA robotic arms, nowadays it has become more popular. So that is there, and another is the BOSS APA system. It is a assistant system basically. So it is a APAS assistant, it is APAS inspector, it is a APAS base. All of these are being created by the Bosch to work in tomorrow's connected industries. So these are basically the flexible network smart factories have been developed for such this. The purpose is that people, machine and products will be communicating with each other, and we know that this is the basic target in the industry 4.0 or smart manufacturing. So this APAS assistance can help in that direction basically. They can be used as mobile and flexible solutions without any guards. So basically they are capable to make the decisions, autonomous movement. Basically they are having a sensor screen. So whenever they detect that they are trying to collide with someone, they will take the corrective action, they will stop, they will reduce their speed and other things. Okay. So this sensor screen helps them to make it more human interactive basically. So this makes it suitable for a wide range of application in which it will work together with the people in a guard-free workplace. We need not to worry when it will be colliding with the people, because when it detects that it will be colliding with the person working there, then it will stop automatically. So the basic aim here is that man is also working and the robot is also working, and they are working in synchronous with each other. APAS assistant is the first robot system to be certified for collaborative operating by German Social Accident Insurance. So it has been certified. So this is the APAS, basically APAS assistant. So if you see here, it is having a mobile platform, so it can move, and it is having an arm, and it is having the sensor screen, right? The APAS assistant is a flexible, mobile, fast learning and connected system. So it has rollers and an easy to operate low. This means it can be put to work quickly and easily at various locations within a production facilities. APAS assistant sensitive 3-finger gripper. It has a 3-finger gripper which is capable of gently or firmly grasping a wide variety of parts with complex geometry. So fingers, it is the major challenge when we design the finger is that complexity of the object we are. So as a human, we are able to take the decision that we can grasp this object in this particular direction and we can lift it. But for robot, making a decision is a difficult task, so a pass helps in that task. Right? It has integrated cameras which help it not only to register its surrounding autonomously, but also to recognize parts for itself and manipulate them with the precision. The operator can use a touchpad control system to teach the APAS assistant. Previously, when initially the robots were designed, basically they were having the facility that first you teach them and then they will be performing the task. So what was done is that by using the controller, touchpad controller, basically previously we have the joke this we use for the playing the games. So this controller is being used to move the robot in different direction from one place to another, and then it will be just what it does. It in the process it was recording the different positions of the robot beeper, and accordingly it will be moving the motors. So teach and then play. Teach and play was the initial aim. So the same thing has been incorporated in the production assistant. So it can be used for the teach and play. So what can be done is that if you are changing the environment or you are having a flexible manufacturing system, so a job has been made, you want to make another job according to the requirement of the different user, then automatically you can easily tease the robot and then it can perform the task, right? So that is the basic aim, basically, right? So they can be called up at any time at the push of a button, right? So these APAS family systems are networked with each other, so collaborative robot you can develop. So they can exchange any work plans they have already been put together. So it makes the whole production system flexible production system. That aims towards the smart control. So the fact that all devices in the family have an Ethernet connection, also high performance remote maintenance. Well, these are some robots in the industry. I just play this video because I forget to mention this. So this is one robot which is just picking from one place and putting it on the other, two parallel. This is another where it is picking and placing. It is another example of pick and place. Right? This is a operation. If you see, this is bending. Basically, it is just like a CNC machine or CNC bending operation. So if you see, these operations are done on the plate. First, it is given a V shape. Then you can, if you see here, it is bending these places, right? So it is folding them, and then it has been placed. So number of operations. So that was the slow speed, and you can see the speed at which it is done. This is the real-time speed. This is another similar type of example. I can speed this. This is the automatically it is performing the sheet metal operation. So the job has been done. Maybe I just play it slightly. So this one is being performed in the Amada bending also. If you see the Amada bending machine, there is Amada bending system. So it is performing different sheet metal bending, and there is no human interface, no human intervention. Everything has been done and then it is right. Here it is performing the operation manipulator robotic arm manipulator. there is some problem with this because it's not being loaded. This is again another human robotic arm manipulator, and then it is picking, placing it at other. So this is also performing the task. The job has been done at this place. It has been picked. It has been transferred here, and then this is some operations, grinding operation has been done. And this is basically augmented reality. If you see here, the robot is doing real-time job, and then we can see it in the. This is collaborative robot. One by one, the robots are working in collaboration with each other. So it is picking the job, it is doing the second operation, and then it is putting. So you can perform the machining operation in other things. This is the bending, pipe bending operation being performed. And then it is placed. This is the painting operation basically. So likewise, you can perform different tasks using the robots. These are the tasks. These are the smart manufacturing applications basically of the robots. Right? Okay. Now I will again this is my last basically. I think the time is already over, but maybe I take 5-10 minutes. What I do is basically I will briefly tell you, and then I will show the video of this. So how BMW has implemented the smart factory technology in their plant basically. This case study I had taken from this website basically. So here BMW that it has modernized the work, and they will be having 60 lightweight robots in series operation by mid of years. So they are aiming towards the collaborative robots, right? And basically, according to Christian Duncan, head of BMW production system planning, he said the digitalization allows the BMW group to take a growing range of options on how to advance the production system in many aspects. People are more than ever becoming the designers of their own workplaces and can provide answers to the questions of an increasing complex automotive production. So here what is happening, the workers, they are designing the workplaces and they can use the robots for their purpose. Right? So purposeful application of this, so they work in collaboration with each other. So here the workers are using the automated measurement systems. So these robotic arms, they are using it for performing the various measurements on the car body. Right? Then interaction of the man and machine. Right? So in South Germany, a ceiling-mounted lightweight robot in the axle transmission assembly lifts the bevel gears, which may weigh up to 5.5 kilo. So they are heavy loads they can lift basically, right? In this production area, workers and robots work together hand in hand in a confined space without any safety fences, because they are working in collaboration, so they don't require any safety fences. Right? Safety sensors monitors the functions at all times and stop the process immediately if an obstacle is detected. So this is the, here in this example, this robotic arm, it is performing the adhesive operation on the windows. So the adhesive to the front window, that makes this task challenging because the viscous adhesive must be sprayed over the large glass surface in one go and without any fluctuation in the film thickness. You require a proper film thickness and you have to perform it in a one go. So robot can help in that direction, right? So this task is carried out by a lightweight robot that works directly at the line with the human workforce, right? Their flexibility, modest space requirement and high level of safety grant people access to area that used to be off limits. Then main machine system, laser-based systems and other things are being developed, right? Here it is the whole assembly, robot engine has been lifted and the robot is performing with the help of this, and robot is performing some task on this. Right? This is how the workers can design their workspace and then they can work in collaboration with the robot. So some tasks the human is performing, some tasks the robot is the. This is the cooker robot. I had already given the example. So these two are working in the collaboration with each other. Right? And then you have the digital production assistance, so you can have the barcode scanners and others to make it Industry 4.0 ready. And the scan process is triggered by the worker pushing a button. Index finger is just pushed by the thumb, and then it will be scanning operation will be performed. That is how they planned it. Right? This is the augmented reality. So at a remote places, you can see the actual work being performed. Right? So augmented reality applications are applied at BMW Group in early phase concept validations, initial sampling inspections, and tool acceptance at suppliers as well as in the maintenance of running systems. Then another thing they had implemented is the exoskeleton. So this exoskeleton can be worn directly on the body, can act like a second skeleton. So it becomes an external support structure for the body. So they use both upper body and lower body exoskeleton. The exoskeleton base for the upper body strengthens the movement of the upper arm, and the waist joints have an integrated mechanical spring, right? 24 such exoskeleton bases are currently in use. Right? Lower body exoskeletons can be found in the production area of several BMW these. So they can act as the chair type support. The workers' posture and offers relief in carrying out assembly tasks that require crouching or remaining in other position that might affect the. So these robots are helping the human beings. And you know nowadays the robots area, one of the robotics area is the human-centric robotics. These exoskeletons can help in this basis, right? So this is the example. So here this worker, it can use a exoskeleton which can perform the actual task instead of him working at a height, right? So that is the, right? So let us see this video. This is the last slide from my side. Although I had overgone my timeline, but let me show you this video and then I will add. It will take time in this. So what I will do is, instead of that, let me show you this. directly in this, because otherwise it will take time there. So, so he's talking about the digitization of the production process. So by augmented reality, you are getting the actual status, and then you can, from a distance, you can decide that what is actually happening. You can plan for the maintenance and other things. This is the inspection system. So this is basically measuring the curvature. This is the pasting, rubber pasting on the winds front. This is the augmented reality basically. If you see the, he's having a camera and then it can be shown on the screen. So whatever the driver is seeing, it can be shown in this basically. So this is the augmented reality. So this is the automation basically. So this is the automatic movement of the tracks and other things which can transport the material from one place to another. So this is the automation basically. This is a part of automation, I can say, because it is not, it is a particular task it is performing. And then it is performing that, it is pushing it from one place to another, moving it, keeping it on the one rake over the another. So the total things are automated. So here you can, it is the lift. Basically, it is a linear actuator which is going, then it is going up. So this is the barcode reader, scanner basically. So when we scan, we can know that what is the robot and the worker, they are working together in this example. So this gear has been lifted, the worker has put, now the robot will be keeping the gear. So now you can see that worker has closed it. So both robot and the worker both are moving in synchronous with each other, and the assembly process can be performed easily without colliding with each other. So this is how the robotics can help in industry 4.0.
Okay, thank you, sir. Now, sir, we can take some queries from the participants. So I request to our participants, if you have any query, please ask.
These are some references. You can see various video regarding the robotics, right? Various, right? Thanks. Any questions, anything? Actually, I had already gone beyond my time limit. Sorry for that.
Yes, sir. We have some questions in the chat box, sir. I don't know, sir, whether participant is there now, but he has posted the question in the chat box. Hello. Hello, sir. Am I audible? Hello. Sir, am I audible to you, sir?
So in case, I don't know, I don't know.
Hello, sir.
I can see one or two questions here. How the performance of robot tasks are tested and modified based on our needs in a factory. So what is done is basically in the factory, when we have planned the task, given task, we have to actually test it. So we have to implement it and then test it. The repeatability and accuracy both are to be checked, and then we can modify it. So it can be done like this, right? Another question is that what type of language is used in robots? Is basically nowadays robots programming has become more user friendly, but one of the MATLAB is Simulink, in which you can plan it. You can do the programming in Python, C language also, you can do it. But nowadays Python is easy to use basically, and various libraries are also, lot of libraries are available. So you can use it Python. The major problem comes is the controller. So controller, how to program this controller is the big task. Each controller has their own programmer. So you can write your program in C or Python, but that has to be converted according to the requirement of the controller. Whether you have the Arduino controller or you have the Raspberry Pi or Fanuc controller or others. Generally Fanuc controllers and others, these Fanuc, they don't give the insight of their controller systems. So we have to be dependent on this. We can only give the commands and that will be executed. Right? Another question was the how user interface path programming will link with the robot. If you see the robot, which it's BMW robot itself, the assembly process, it was picking the gear from one place and it is to be placed at other position. So there is a trajectory planning basically. In manipulator we call it as the trajectory planning. In mobile robots we call it as the path planning. So path planning, we have different algorithms like A-star algorithm and bug 1, bug 2 type of algorithms are there. Other algorithms have been developed, so you can use them for the path planning purpose. Similarly, for trajectory planning also, you can use this type of A-star algorithm also you can use. Both path planning and trajectory planning are similar in the sense, only thing, the difference is that in path planning we are moving on a horizontal platform, while in the trajectory planning we are moving in the 3D space. And does UI paths will have future in it? Yes, it is very much required because industry 4.0 means we are moving towards more flexibility. So you have to program your robot according to the need, basically. Suppose we are changing the shape of particular component or particular object to be changed, that means my path will be changing. So obviously we require the planning accordingly, right? SCARA robot used in the automotive industries. Initially it was used, basically SCARA was basically the assembly robot. So we pick from one place and place it another place. For example, the last, again I go to the last video basically, where the gear was picked from one place and it was placed another place. So you can use the simple SCARA robot if the two places are fixed. But if the distance between them is changing, orientation is changing, then we cannot use the SCARA robot in such cases. Teach-pendant robots are teach-pendant robots used now in 20th century. It is just to train the robot. Basic aim is that. So what you can do is you can teach the robot, then you can use the nowadays artificial intelligence. So initially by teaching them, you get the insight. Basically, so when you perform the ANN type of this, first the learning part is there and then the actual actuation part is there, right? So in the learning phase, you can use this teach-pendant things basically. Is there any MPN robots prevailing across globe? I don't have much knowledge about this, but I think Boston is developing MPN robots. Boston is working on this. So these are the questions I could see.
Excuse me, sir.
Towards the end, but in between some questions are there.
Hello?
Can you repeat here once again? Repost it.
Can I come in, sir?
Then me. Yeah, MPN robot means they can walk, they can roll, and they fly and swimming. So MPN, when we talk about, particularly it is moving over the surface and when it is moving in the water. So particularly if you see the surface robots are well developed, you see the aerial robots are well developed, but still work is going in the water robots basically. So the MPN robots, although the Boston is working, I'm not very sure whether they'd be. I'd seen one video in which they had shown something, but not exactly remember this. So that is why I commented it that it is not being developed.
So I have one question.
It is according to my knowledge, basically.
Can I come in, sir?
Okay. Any other question?
Yes, sir. One question is there. Hello.
I think you're not audible to, sir. I think so.
Okay, I will just write down.
Robots used in defense sector as war robots, researchers and development.
You can write your query in the chat box.
Robotic exoskeleton to soldiers. Yes, the exoskeletons have been developed in India also. Basically, DRDO has developed some exoskeleton for soldiers. For bomb diffusion, basically they use it. Defense sectors, basically they are using. Then one particular applications where in defense sectors they are working basically that loading of the ammunition on the these guns, carriage and other things. There they are working on this. So we are located near the GCF, so we are working on one such application of robot in which the ammunition is to be loaded in the
I have written it.
gun carriage basically.
Yes, sir, will read it. Sir,
That is there, right? What is the role of control, resolution, repeatability and accuracy? Control is a crucial part. Everything in the robot depends upon the control. And if you compare, I'd shown you the MIT Cheetah or I'd shown you the Boston robots. It is the control which is the major part there. Because you have to make a decision quickly. For example, the handle, when it has taken a jump and when the two legs are touching the ground, it has to instantly balance it, because one slow motion it is shown. It was just trying to fall down, but it was balancing. So that requires a precise control. Precision is important. And then the precision means repeatability also, because otherwise it has to do multiple calculations. Right? So that is there. Right?
Sir, am I audible to you, sir?
Okay,
Hello.
any other question, anything? If you have any other question, you can just mail me at vkgupta@iitdmj.ac.in. I will reply you. Whatever knowledge I have, I will share you. Okay. Thank you very much. I think I can end this presentation. Narendra. हाँ, मुझे कुछ सुनाई नहीं दे रहा इधर से, इधर। हाँ ठीक है, चलो, हाँ ठीक है, बंद कर। Okay, thank you very much everyone for patiently hearing.
Yes.
Bye.
Bye.
Thank you. Okay, so dear participants, this is for all. This is for today.
I am leaving now. Okay, thank you.
Okay, sir. Okay, sir. Thank you. Okay, so tomorrow we again will meet at 10 a.m. Okay. So now you can leave the meeting. Thank you.
So today's session was very good.
Thank you. Thank you. Thank you.
Yeah.
We are trying to arrange the good speakers. Okay. So
Yeah.
all sessions.
Very good. It's very interesting. Both the hours, first hour also, second hour also.
Okay. Thank you.
Thank you, sir.
Thank you, sir. Thank you very much, sir.
Welcome.
गुड इवनिंग नरेंद्र सर।
हाँ बताइए।
सर लास्ट में या फिर एफडी कंप्लीट होने के बाद आप पीपीटी भेजिएगा ना, या फिर हम
एक्चुअली सर ऑलरेडी यूट्यूब पे वीडियो रहेंगे, है ना, तो आप यू कैन गो देयर एंड यू कैन वॉच द वीडियो लेटर ऑन।
अच्छा यूट्यूब लिंक से ही हम जो भी रेफरेंस कर देंगे।
ऑल द वीडियोस विल बी देयर। ओके, सो इन फ्यूचर आल्सो इफ यू वांट टू means again you want to study the robotics and automation and any kind of lecture you want to study again, then you can go there.
ओके सर, एंड माय पर्सनल क्वेश्चन इज, मैं तो आपका पिछला जो 2-3 था ये एफडी की, वो भी अटेंड किया था, उसका सर्टिफिकेट कुछ रिलीज हुआ है सर अभी तक?
Okay, you can mail me. Okay.
Okay, ठीक है।
Yes, I won't answer you, but you can mail me.
हाँ, राइट।
Thank you.